Hey guys, tonight we step away from the loud little world that insists everything is urgent, and you slide into something older, quieter, and far more dependable. You're in bed, eyelids heavy, and the ceiling stops being a ceiling. It becomes open sky, deep black, scattered with stars that don't sparkle for attention. They just sit there, steady and unbothered, like they've never heard of deadlines. Somewhere out there is the sun, off right now for you, hiding on the other side of the planet. That makes it easier to imagine it without squinting. Picture a warm coin behind a thin veil, patient, waiting its turn. While you're trying to relax your jaw, that star is doing its job with zero drama. Like a machine so reliable, it doesn't even bother asking for applause. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like it, drop your location and your local time in the comments, because it's oddly soothing to picture this story traveling across time zones, like a soft signal that finds you wherever you are. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin far out, where space is clean and quiet, and the sun is a bright circle against the dark. From a distance, it looks simple, almost flat, like a child's drawing. Round, glowing, done. But distance is a liar. You glide closer, and the light feels thicker, as if brightness could have texture. It doesn't flicker like a campfire. There's no smoke, no snapping flames. It's smooth radiance, steady, overwhelming, polite in its own terrifying way. Slip inward, and the idea of a surface starts to feel suspicious. A surface implies an edge. The sun doesn't really do edges. It does layers, one region blending into the next, each one warmer, denser, more crowded. It's like walking through fog that slowly becomes mist, then rain, then ocean, and you can't name the exact moment it changes. You just feel the deepening. What's strange and calming is that the deeper you go, the less chaotic it feels. You might expect the center of a star to be all tantrum and violence, but the interior begins to feel like the deep sea. Intense, yes, but steady. Far above, the sun can throw magnetic storms and bright flares, like it's showing off for satellites. Down here, it isn't performing. It's simply being. Pressure greets you first, not as pain, not as a threat, but as presence. Imagine stepping into a crowded room where everyone is close, and yet nobody panics because the rules are clear. Everyone moves, everyone bumps, everyone shares space, and somehow the whole room stays calm. That's the sun's core in a sentence. Crowded, busy, unbelievably disciplined. Here's a fact that soothes like a steady heartbeat. The core is stable. Not stable like a chair that doesn't wobble, stable like a balance held for billions of years. Gravity presses inward, calmly, endlessly, like a heavy blanket that never shifts. And the core supports outward with energy, not in a dramatic shove, but in a constant counterpressure. You don't feel a war. You feel an agreement. Inward squeeze, outward support, held in place like a quiet truce the universe never renegotiates. And physics down here doesn't get moody. It doesn't wake up and decide to be different. It follows rules with the kind of consistency your nervous system secretly craves. If your day was full of unpredictable messages and people who say quick question and then write a novella, this place feels like the opposite of that. Predictability on a cosmic scale. Keeps sinking and matter stops behaving like the matter you're used to. On Earth, solids hold shape, liquids pour, gases drift. Inside the sun, it's a hot, charged soup. Particles moving too fast to settle, constantly interacting, constantly sharing energy. And yet it isn't messy. It's organized by pressure and gravity into a steady flow that holds the sun's shape from the inside. If you let a few gentle numbers float past without gripping them too tightly, you get the scale. The temperature is around 15 million degrees Celsius. The density is immense. The pressure is so high it sounds fictional. But the relaxing part isn't the size of the numbers. It's what they produce, steadiness. Minute after minute, the core behaves the same way. Year after year, it keeps the same calm rhythm, like a heart you never have to manage. You can almost sense it as a low hum. Not loud, not sharp, more like the faint vibration of a refrigerator in a quiet kitchen at midnight, the kind of sound you only notice when everything else settles. The sun's core is that background hum, the unseen engine that makes the bright outer layers possible. This is where the sun's power begins, deep in an inner fraction, not spread evenly through the whole glowing sphere. From far away, it's easy to assume the entire sun is equally intense, like a uniformly heated ember. But it's more selective. The deepest center is where conditions become extreme enough for the star to keep being a star. You don't need the fine print tonight. It's enough to feel the simple truth. The warmth you know has an origin point, and you're floating in it. And that warmth is oddly personal. Sunlight feels casual, landing on sidewalks, warming your face, making the world look kinder by a window. But it begins here, in a place that's crowded and patient and held tight by gravity. It starts in a region that doesn't care about you, and still it shapes your days. The universe doing its own thing, and you benefiting without being asked to earn it. That's a softer thought than people give it credit for. Time down here is the real lullaby. The core has been steady for longer than any human story, and it will remain steady on timescales that make today's worries look small. Not silly, just small. Your problems live in hours and weeks. The core lives in slow, faithful stretches of existence. Holding that contrast doesn't erase your life. It loosens the tight grip your thoughts sometimes keep, glide closer to the center, and the imagery becomes almost abstract. No fallirica voz, no villain life. Just density, motion, containment. The core doesn't feel angry. It doesn't feel desperate. It feels like a calm heart, immense, powerful, and steady. A heart doesn't perform. It simply keeps rhythm, and everything else builds on that reliability. If your mind tries to sprint ahead, bring it back to the simple steadiness. Gravity pressing inward, the core supporting outward, the sun holding its shape without asking for your attention. The sun can afford to shine wildly on the outside because the inside is disciplined. And you can afford to let the day loosen and fall away because something unimaginably huge is holding itself together, quietly, perfectly behind your eyelids. Stay there for a moment, right in that crowded calm, and notice the comfort of certainty. Gravity presses in. The core supports out. The sun keeps its promise. No speeches, no slogans, just physics, faithful and steady. And in that steadiness, you can feel deeper mysteries waiting behind the hum, like doors you'll open one by one, without forcing anything, just letting curiosity unfold at the speed your body likes. That steady squeeze you were feeling doesn't fade just because you're getting used to it. If anything, it becomes clearer, like your ears adjusting in a quiet room until you notice the soft hum you ignored before. Gravity is the hum. It's everywhere, in every direction, and it never gets bored of doing the same simple thing, holding the sun together. On Earth, gravity feels like background. You stand up, you sit down, you drop your phone on your face at the exact moment you start to relax. Gravity stays consistent through all of it, which is honestly rude, but at least it's dependable. In the sun, that same dependability becomes the main event. Not a performance, not a spectacle, more like the rules of the building. The sun exists because gravity refuses to negotiate. The bright disk you know from daytime is up close, a restless sphere of moving matter, nothing that would politely stay put on its own. Without gravity, it would spread out like a fog that forgot why it was trying. Gravity is the reason it doesn't. Gravity is the reason there's a center to drift toward, a reason for down to mean anything in a place with no floor. As you sink inward, you feel what gravity really means here. Not just a pull, but a deep, constant pressure created by the weight of everything above. The outer regions of the sun aren't light in the casual sense. They are unimaginably heavy when you stack them together. Every layer presses inward because every layer is being pulled inward, and that makes the inner regions carry the burden of the whole star. It's like being under an ocean, except the ocean is made of the sun itself, and the water is glowing material, dense and bright. It's tempting to imagine that pressure as something violent, like a crushing vice. But the core isn't a brittle object being squeezed until it breaks. It's a living, shifting interior where particles are already colliding, already sharing energy, already part of a constant crowd. Pressure here is not a sudden attack. It's the normal state of existence. It's the sun's version of comfort. Oddly, the core is safe because it cannot be loose. It cannot unravel. It's held too well. That's why no escape clause sounds ominous but feels calming. Your life is full of escape clauses. Plans get canceled. People change their minds. Promises evaporate. Even the weather can't commit. Gravity, though, gravity commits. The sun's core can't decide to wander off into space. Individual particles can move fast, sure, but the overall mass of the sun creates a gravitational well so deep that the star remains bound. The core stays a core because the rest of the sun is still there above it, pressing inward. And there's something quietly funny about how impersonal it is. Gravity doesn't care whether you manifest a lighter workload. Gravity does not read self-help books. Gravity does not scroll. Gravity simply pulls, and in that pulling it creates stability. Humans, meanwhile, invent all sorts of questionable hacks to feel protected. Legendary-sounding ideas like crocodile dung sunscreen, for example, because apparently someone looked at a reptile and thought, this is the skincare brand ambassador I deserve. If you trace the sun back to its beginning, gravity is the first storyteller. Long before there was a bright sun and a blue earth, and you lying here listening, there was a drifting cloud of gas and dust. Cold, thin, unimpressive, but in one region the cloud was a little denser. That was enough. A small imbalance, a small preference for more here than there, and gravity began to tighten the cloud's shape. Not quickly, not with drama. Slowly, patiently, like fog deciding to become rain. As the cloud collapsed, the center grew denser. Falling inward converts gravitational potential energy into heat, not because anything ignites, but because particles crowd together, collide more often, and their motion becomes more frantic. The early sun was warmed by that squeeze alone, like hands rubbing together in the dark. Gravity didn't create fire. It created compression, and compression created the conditions for a star to become steady instead of scattered. The calming part is how gradual it all is. Stars aren't impulsive. They don't flip from off to on in a single moment you'd call an event. The sun's core became the core through a long settling process, one that rewards patience and punishes panic. A little more collapse, a little more heat, a little more density. The kind of slow progress your nervous system loves, even if your calendar does not. And once the sun became a proper star, gravity didn't stop. It kept applying the hug. It kept insisting on togetherness. That insistence is what makes the core a stable engine instead of a random furnace. The moment anything inside tries to change too much, gravity becomes a quiet correction. The sun regulates itself in the most unromantic way possible. If the core gets a little hotter and expands even slightly, the density drops. With particles a bit more spread out, collisions become a bit less frequent. The conditions soften. The core cools back toward its steady state. If the core cools and shrinks, density rises, collisions become more frequent, and the conditions drift back the other way. It's not a conscious system. It's just physics nudging extremes back toward the middle without speeches or opinions. That self-correction is one reason the sun can shine for billions of years without the kind of tantrum you'd expect from something so powerful. A candle is fragile because it lives on a thin edge, a small flame, a little oxygen, a breeze away from failure. The sun's core is not living on an edge. It's living under the weight of nearly the entire sun. There is no breeze. There is no quick collapse into nothing. There's only the slow, steady grip of mass, quietly holding the conditions in place. You can sense that grip as you drift. Above you, layers upon layers press inward. Around you, matter swirls and collides in crowded motion. And yet the overall feeling is steady. It's like lying under a heavy comforter while rain taps the window. Movement and sound outside, stillness and security inside. The core is the inside. Gravity makes it feel like the safest place and the most dangerous object you've ever benefited from. There's another comfort hiding in the geometry. At the exact center of a sphere, directions begin to lose their meaning. When you're surrounded by mass equally on all sides, the net pull points nowhere. It doesn't mean gravity isn't present. It means gravity is perfectly shared. Every tug is matched by another tug. It's the still point inside the hug. The center is not peaceful because nothing happens. It's peaceful because nothing is allowed to happen in a lopsided way. So the core sits in this paradox, held by everything, pulled from every side, and yet centered. Pressed, and yet stable. Busy, and yet steady. Gravity creates a kind of cosmic permission to relax. The sun does not need constant supervision. It does not need you to worry about it. It has been held for longer than human memory, and it will keep being held long after the last message you read today stops mattering. You rest in that thought. Gravity is not soft, but it is reliable. The core isn't calm because it's gentle. It's calm because it is contained. And containment is comfort when it's consistent. The squeeze continues, not as a threat, but as an assurance that the sun's deepest work can go on without interruption, turning that endless inward pull into heat that isn't flame, warmth that doesn't flicker, and a kind of burning that isn't burning at all. That reassurance, gravity committing with the stubborn loyalty of a cosmic weighted blanket, makes the next truth easier to accept without your brain trying to argue with it at 2 in the morning. Because if the core is being held so tightly, you might assume everything inside is burning, raging, flaring, doing the whole dramatic fire thing. Your mind reaches for the closest metaphor it has: flames, campfires, stove burners. That one time you try to toast something and accidentally invented charcoal. But down here, burning is the wrong word. It's a cozy word, honestly. Familia. Human scale. It belongs to oxygen, sparks, and the kind of heat that comes with smoke and smell and regret. The sun's core doesn't do that. There's no air, no oxygen waiting around to react like an overeager intern. No flame licking upward, because upward isn't even a concept in a place where you're surrounded by mass and pressure from every direction. So when someone says 15 million degrees and your brain pictures a bonfire with attitude, it helps to soften the meaning of temperature until it fits what's really happening. Temperature, down here, isn't a color or a vibe or a feeling on your skin. It's a statistic, a quiet, relentless average. It's the measure of how wildly particles are moving, how much kinetic energy they carry as they zip, collide, bounce, and ricochet through an environment so crowded it makes a subway car feel spacious. Imagine a room full of ping-pong balls, all of them moving. At low temperature, they drift. At higher temperature, they zip. At the core's temperature, they're basically a chaotic ballet performed by billions upon billions of microscopic dancers who never get tired and never stop bumping shoulders. Not because they're angry, not because they're trying to burn anything, just because heat, in its simplest form, is motion. This is where the phrase, "it would burn you up," gets a gentle reality check. On Earth, heat hurts because your body is a nice, delicate system built for narrow conditions. But you don't get burned by a number. You get burned by energy transferring into you fast enough to overwhelm your structure. The core is violent only in the sense that it's full of collisions. And those collisions are constant. So constant they form a kind of smoothness, like a waterfall that looks silky from far away because it's too continuous to track. That's why the core feels oddly calm again. Yes, particles are moving insanely fast. Yes, the conditions are extreme, but the extremes are uniform. There's no sudden gust of oxygen, no flickering flame, no soot, no chaotic pockets of more fire here, less fire there. It's a stable environment where motion is intense and predictable. And predictable is the part your nervous system likes. Your anxious thoughts are unpredictable. They pop up like ads you never agreed to see. The sun's core doesn't do pop-ups. It does averages. It does steady distributions. Most particles moving fast, some moving faster, a few moving ridiculously fast. And that spread matters, because it's the secret way the core does its deepest work without turning into a fireworks show. The word burning also suggests something is being consumed quickly, like a log in a fireplace crackling down to ash. The sun doesn't spend its fuel like that. It spends it like a careful saver who still reuses the same paper bag. The core's main process isn't chemical combustion. It's nuclear fusion, a slow conversion where hydrogen nuclei ultimately become helium. That's not a flame. That's a transformation in the nucleus itself, on a level far deeper than chemistry ever touches. Chemistry is about electrons, those outer, fussy little arrangements that decide whether something smells like citrus or whether crocodile dung sunscreen is a crime against nature. Nuclear reactions don't care about your skincare routine. They happen in the heart of atoms, where protons and neutrons live, bound by forces that make chemical bonds look like a sticky note. So the heat in the core isn't fire. It's the environment that allows nuclei to collide often enough, with enough energy and enough probability, for fusion to occur at a steady rate. And probability is a surprisingly soothing concept in a place like this. It means no single collision has to be heroic. No single moment has to carry the whole story. It's a vast crowd of particles colliding endlessly, and every so often, thanks to the tail end of that speed distribution, conditions line up and fusion happens. Not all at once, not in a tantrum, in a rhythm. Your brain might try to protest, but 15 million degrees should be like more dramatic. It's okay. That's just your brain's Earth-based metaphor engine working overtime. On Earth, 15 million degrees would be a headline, a disaster, a cinematic explosion that leaves the soundtrack ringing. In the sun's core, it's just Tuesday. And it has to be, because this system is regulated. Remember that gentle correction gravity provides? That thermostat-like behavior? It works here too. If the core's temperature rises, the core expands slightly. Expansion lowers density. Lower density reduces collision frequency. Fusion slows a bit. The temperature drifts back down. If temperature drops, the core contracts, density rises, collisions become more frequent, fusion nudges back up. It's stability built into the physics, like the sun was designed by someone who hates surprises. That's one of the most relaxing facts about the sun's core. It is self-stabilizing. It doesn't need babysitting. It doesn't need a committee meeting. It doesn't spiral because someone said the wrong thing in an email. It adjusts because the rules of nature gently push it toward balance. The other soothing truth is that hot doesn't mean bright in the way you think. The core is not a glowing lantern you could see if you somehow had transparent sun walls, which, thank you for not requesting, because that mental image gets weird fast. The core is dense. Light inside doesn't travel freely. Photons get absorbed and re-emitted, scattered again and again, jostled like someone trying to cross a crowded room, while everyone insists on stopping to chat. So the core's heat is real, but it's trapped in a way that makes it feel less like a blaze and more like a deep pressure cooker of energy. The brightness you associate with the sun is what happens after energy has moved outward through layer after layer, eventually reaching regions where photons can finally slip away into space and run straight to your face like they've been waiting their entire lives for this moment. That movement outward is part of the core's calm too. Energy doesn't explode out. It leaks. It diffuses. It takes its time. It's the slowest commute ever. The kind that makes you grateful your own commute is just rolling over and reaching for water. Another small, sleepy adjustment in your mental picture. The core is not a place where atoms sit politely intact. At these temperatures, electrons are not hanging around their nuclei like loyal pets. Matter is ionized plasma. Nuclei and electrons move separately, like a crowd that's lost all the pairs. That means touching things, burning things, flame behavior, all the sensory language your brain uses, doesn't apply neatly. Instead, you get a charged soup where electric forces matter a lot, collisions are constant, and everything is energetic but not theatrical. A particle can slam into another particle, and that's just normal. That's the baseline. The chaos is so complete that it turns into a kind of smoothness. You can feel how that would be calming if you were made of equations instead of feelings. And since the core is made of physics, it gets to live the dream. Still, the words 15 million degrees can sit heavy. So take a softer route. Temperature is motion. Motion is energy. Energy, in the core, is contained. Containment is stability. Stability is why the sun doesn't flicker out or flare up randomly. And stability is why you can lie here and trust that the sun will be there tomorrow without you having to check the forecast for catastrophic star failure, which would be an annoying push notification, honestly. It's also comforting to realize that the core doesn't want to burn faster. It can't suddenly decide to become a bomb. Explosions come from runaway reactions, rapid increases that feed on themselves. The sun's core runs on a delicate balance of pressure, temperature, and density, and that balance includes built-in brakes. Even fusion itself is not something that accelerates wildly under normal conditions, because it depends so strongly on temperature and density, and those are chained to gravity's constant hug and the core's response to changes. So what you have is the opposite of fire. Fire is hungry and fickle. Fire needs oxygen. Fire races. The core is patient and contained. It doesn't need oxygen. It doesn't race. It hums. And the hum has a second layer of calmness if you zoom out to meaning. The sun's core is the source of nearly everything familiar in your world. The warmth in your room during the day, the weather patterns, the energy plants store in leaves, the slow conversion of sunlight into food and movement and thought. It all begins with motion inside a crowded plasma, held by gravity, regulated by balance, turning the universe's simplest element into something slightly heavier, one quiet step at a time. If your mind wanders back to something trivial, an awkward conversation, a missed task, the weird sound your fridge made, notice how the scale of the core doesn't shame you. It just makes your worries less sticky. The sun's deepest engine doesn't care, and that's freeing. The core has been steady for so long that it gives you permission to be steady for the next few minutes. Nothing needs to be solved tonight. The core isn't solving anything. It's just doing what it does. You stay with that. Heat as motion, not flame. Intensity as steadiness, not chaos. And somewhere in the back of your mind, another mystery waits. How the sun manages to do this impossible nuclear work without dramatic shortcuts. How the tiniest quirks of physics turn into the most reliable light source you've ever known. That picture of heat as motion settles into you, and it makes the next shift feel almost effortless, because if burning isn't really burning, then the stuff doing all that moving isn't really gas either. It's something stranger and smoother. You're floating in a place where matter has been peeled down to its essentials, like the sun took the universe's most basic ingredients and said, with quiet confidence, "We're not doing costumes today." Inside the core, atoms don't get to keep their neat little architecture. On Earth, an atom is usually introduced like a tidy solar system. Nucleus in the middle, electrons orbiting politely around it. Goo, comforting. Slightly misleading, but we'll allow it because school needed a diagram. In the sun's core, that picture dissolves. The temperature is so high that electrons aren't orbiting in any cozy, loyal way. They're ripped free. The nuclei, mostly protons, some helium nuclei, a whole busy mix, move through a sea of electrons that are just as energetic. Everything is charged. Everything responds not only to collisions, but to electric forces that reach out and tug across tiny distances like invisible strings. This is plasma, the sun's everyday state of matter, and it's the part that feels most like a living crowd. A gas can be thought of as a bunch of particles mostly minding their own business until they bump into something. Plasma is a bunch of particles that can't stop affecting each other, even when they aren't directly touching, because charge turns personal space into a suggestion rather than a rule. And that crowd feeling is oddly calming, because you can sense a kind of collective behavior. It's not just random chaos. It's a system. When charges move, they create electric currents. Those currents can create magnetic fields. Those fields can guide motion. In the core, everything is so dense and so collisional that motion is constantly being shared and redistributed, like a room where nobody can keep a secret because everyone keeps bumping into everyone else. You might expect that a soup of charged particles would be wild and sparky, like a sci-fi storm. That's your Earth brain again, trying to turn everything into lightning for the sake of entertainment. The core doesn't need entertainment. The core needs stability. The plasma here is so thick, so pressed, so relentlessly crowded that it behaves more like a smooth, heavy fluid than a crackling electrical show. It's like the difference between a static shock from a doorknob and the deep, steady pressure of the ocean. Both involve forces you can't see, but one is a jump scare and the other is a constant embrace. If you focus on the feeling, plasma in the core is softness made from intensity. It's fluid, it's hot, it's dense, and it's held in place. It doesn't have a surface you can tap. It doesn't have corners. It has motion and pressure and an unbroken continuity, as if the sun's interior is a single breathing thing. Except it doesn't breathe because it has no lungs and no need for drama. The weird comfort is that plasma doesn't behave like millions of individual stories. It behaves like one big story with endless tiny characters. You can imagine a single proton rushing through this environment, but it never stays alone for long. It's surrounded by electrons that rearrange around it, like a crowd subtly shifting to accommodate someone moving through. Charges screen each other. Regions of slight imbalance get smoothed out because the plasma is so good at rearranging itself. It doesn't like local weirdness. It doesn't like sharp differences. It prefers equilibrium the way your body prefers a steady room temperature over a sudden blast of cold air. Even the word screening feels cozy. You picture the plasma helping itself, constantly minimizing extremes. A positive charge won't sit there naked and isolated in this environment. Electrons gather nearby, reducing the reach of its electric influence beyond a small region. That means the plasma can be incredibly interactive on small scales while still behaving calmly on larger scales. Close up, it's all tugging and rearranging. Zoom out, it's smooth. That dual nature is part of what makes the core feel like a quiet engine rather than a chaotic mess. And because the plasma is so dense, collisions happen constantly. Particles don't travel far before they interact. Every shove is followed by another shove. Every burst of motion is redistributed. That constant sharing creates a kind of thermal fairness. No one particle hoards the energy. Energy spreads, like warmth spreading through a blanket you've been under for long enough that there are no cold patches left. It's worth letting your imagination slow here because plasma is often introduced as this flashy fourth state with neon vibes, and sure, plasma can look like that in certain settings. But the sun's core plasma isn't glowing for your camera. It's too deep, too dense, too hidden. The brightness you think of as the sun is mostly a surface-level phenomenon. Down here, plasma is about conditions, not visuals. It's about motion, charge, pressure, and the quiet rules that keep everything from tearing itself apart. The core's plasma is also a kind of honesty test for your mind. You can't lean on familiar sensory language. You can't say it's like air or like water and be done with it. It's its own thing, and that's part of the fascination. If your thoughts usually race because you're trying to control everything, plasma offers an alternative. Accept the rules, watch how beautifully it self-organizes, and stop trying to force it into a metaphor that doesn't fit. Somewhere in the back of your mind, a tiny voice may ask, if everything is charged, why isn't the core just one big electric situation? You know the kind. The kind that would make your hair stand up and your phone stop working and your crocodile dung sunscreen spontaneously combust, which would at least solve one problem. The answer is one of those calming physics truths. The core stays close to electrically neutral overall. There are plenty of positive charges and plenty of negative charges, mixed together so thoroughly that the large-scale net charge is basically zero. The plasma is charged at the particle level, but balanced at the big-picture level, like a crowded room where everyone has opinions, but the group as a whole stays remarkably civil. That balance doesn't mean nothing happens. It means what happens is controlled by the crowd rules. If electrons drift a little one way, fields appear that tug them back. If ions drift too much, they get dragged by collisions and forces and pulled back into the general flow. The plasma resists extremes. It dampens wild separations. It constantly tries to return to that smooth, steady state. And this is where the core's calm begins to feel almost personal. Your own body is a system that tries to maintain balance, temperature, chemistry, rhythm. When something shifts, you have feedback loops, sweat, shiver, hunger, fatigue. The sun doesn't have feelings, but it has feedback loops too, and plasma is the medium that lets those loops work. It's responsive, it's conductive, it's quick to redistribute. In a strange way, plasma is the sun's way of staying sane. The more you sit with it, the more the core feels like a place where everything is forced to cooperate. Not because there's a leader, not because there's a plan, but because the environment leaves no room for selfishness. You can't be an isolated atom with your own private electron entourage. You can't be a lone particle with a dramatic storyline. You are part of the crowd, and the crowd is the system, and the system is held by gravity's hug. And gravity, always gravity, keeps the density high enough that the plasma remains a tight-knit community. If the core were more expanded, if everything were more spread out, interactions would be less frequent, the crowd would loosen, and the character of the plasma would shift. But here at the center, it stays intimate. Particles constantly nudged into each other's presence, constantly sharing energy, constantly smoothing out any sharpness. There's a quiet magnificence in how simple the ingredients are. Mostly hydrogène nucléaire, proton plus hélium nucléaire, plus électron. That's it. No fancy molecules. No complex chemistry. No ornate structures. It's like the universe stripped away all decoration and said, these are the basics, and they're enough to make a star. The grandeur doesn't come from complexity. It comes from scale and consistency. Billions of years of steady motion from the simplest stuff. If you imagine yourself drifting through this plasma, not as a fragile human body, because that's an unpleasant thought experiment, but as a point of awareness, you'd sense that there's no place to stand. No solid ground, no air to breathe, just motion all around, like being suspended in a warm current that never stops. The current isn't rushing. It's restless, but evenly restless. The kind of motion you stop noticing because it becomes the background. That background motion matters because it sets the stage for everything else the core does, but the stage itself is already hypnotic. Plasma makes the sun feel less like a burning object and more like a contained sea of charged motion. A sea that doesn't splash because it's packed too tightly. A sea that doesn't freeze because it's too energetic. A sea that doesn't evaporate because gravity won't allow it to drift away. And there's one more soothing angle to plasma, something almost tender. It's forgiving. If a region gets slightly hotter, particles spread out a bit, collisions change, forces shift, and the system adjusts. If a region gets slightly cooler, density changes, interactions shift, and the system adjusts. Plasma is not rigid. It's adaptable. It's a medium that can flow and respond while still holding the sun together, like a living cushion inside an unbreakable hug. You linger in that thought, and the core's mystery deepens without becoming loud. Not a flame, Not a furnace you can picture with brick walls and orange tongues of fire. A dense, charged ocean of motion, organized by pressure and balance, humming with energy that stays contained and patient. The sun's core doesn't scream its power. It holds it, shares it, and lets it out slowly, the way a steady heart releases life one beat at a time. That dense, charged ocean you've been floating through has a personality you can feel even without seeing it. Restless but controlled, crowded but oddly polite, as if the whole core has agreed to keep its voice down. Beneath the constant bumping of particles, a deeper rhythm keeps repeating, quietly, faithfully, like a pulse your body starts matching once you stop resisting. This is the sun's real habit, fusion. Fusion sounds like it should come with fireworks. Your brain wants a cinematic flash because humans love power that looks loud. The core refuses the performance. It produces the greatest steady output you've ever benefited from by doing something almost boring on purpose. Tiny reactions happening calmly, controlled by probability, repeated so many times they become daylight. The relaxing twist is that fusion here is difficult. Hydrogen nuclei, protons, don't want to join. They're both positively charged, and positive charges repel stubbornly. Two protons trying to combine is like two people in stiff winter coats attempting a hug in a narrow hallway. They bump. They recoil. They both pretend it was fine. That repulsion creates a barrier. To fuse, protons must get close enough for the strong nuclear force to take over. The strong force is a different set of rules. At extremely short distances, it's intensely attractive, binding particles together with a grip that makes electric repulsion feel like a mild objection. The problem is reaching that distance. Heat helps because heat is motion. In the core, protons move fast and collide constantly. The crowd is busy, collisions are energetic, and there are endless opportunities. Still, most collisions end the same way: bounce and separate. That's not a glitch. It's the sun's built-in patience, the reason it doesn't burn through its fuel in a loud, short life. So the core relies on a quieter trick, one that feels like the universe opening a secret door. Quantum tunneling. In everyday life, if you don't have enough energy to climb over a hill, you don't get to the other side. You roll back down. Classical physics loves that kind of certainty. At proton scale, reality gets softer. Particles are described by waves of probability as much as by things with edges. Those probability waves can leak into forbidden regions, like mist seeping under a closed door. Most of the time, the mist doesn't make it through. Sometimes it does. That's tunneling. A proton occasionally ends up effectively on the other side of the electric barrier, close enough for the strong nuclear force to grab it. Not because the proton broke the rules, but because the rules at this scale are written in odds, not guarantees. The sun's core is a place where rare becomes routine simply because the number of tries is absurd. You can sense how the core uses this. It keeps protons packed together. It keeps them moving. It gives them attempt after attempt, trillions upon trillions of near misses. The tunneling probability stays low, which keeps the sun stable. It isn't zero, which keeps the sun shining. Calm, balanced, relentless. Follow one proton for a moment. Just a point of positive charge bouncing through the plasma crowd. It gets nudged by electrons, shoved by other protons, redirected by collisions so frequent it never travels far without meeting someone. It tries and fails and tries again, and it doesn't get impatient because impatience is a human hobby. A typical proton can spend an absurd amount of time waiting before it successfully fuses. The core's power comes from patience at scale, not urgency. When the rare moment happens, fusion begins with the sun's most common routine, the proton-proton chain. Two protons get close, and then a step occurs that is both tiny and monumental. One proton transforms into a neutron. That conversion happens through the weak nuclear force, famously slow compared with the others, like the careful person in a group project who refuses to rush. The slowness is a built-in speed limit. It's a major reason the sun can keep shining for billions of years instead of burning out in a rush. That transformation produces deuterium, a nucleus with one proton and one neutron. A positron is released, an anti-electron that quickly meets an electron and disappears in a neat flash of energy. And a neutrino slips away too, almost ghost-like, barely interacting with anything as it leaves the core behind. It doesn't pause to be appreciated. It just goes, carrying a whisper of what happened deep inside. Deuterium doesn't stay alone long. It collides with another proton and becomes helium-3, releasing energy as a high-energy photon. That photon is not the warm sunlight that lands on your skin. It's born sharp and intense, and it immediately gets caught in the crowd, absorbed and re-emitted, redirected again and again, beginning a slow migration outward that smooths it into something gentler. Then two helium-3 nuclei fuse into helium-4, releasing two protons back into the plasma. In the bookkeeping, 4 protons have effectively become one helium nucleus, plus energy and a few fleeting byproducts. The helium nucleus is slightly lighter than the total mass you started with. That missing bit isn't lost, it's converted. Helium is more tightly bound than the protons that made it, so the difference shows up as energy released into the core's plasma. Energy that becomes motion, pressure, and the steady outward push that holds the sun up against gravity. It's oddly comforting that this grand star runs on a tiny accounting detail. A small change in mass becomes a usable amount of energy because nature has an outrageous exchange rate at nuclear scales. The sun doesn't need a giant reaction to make a difference. It needs countless small ones spread out so evenly that the core stays calm. And this is where the not fireworks part settles in your chest. The sun is powerful precisely because it's restrained. The steps that matter most are rare. The odds are low. The slow, weak force conversion acts like a governor on an engine, keeping the pace smooth. Even if conditions nudge a little, the core responds by expanding or contracting, changing density and collision rates, leaning back toward balance. Gravity squeezes, fusion supports, and neither side gets to spiral. There's a quiet magnificence in how your daylight begins as a rare, tunneling success in a crowded plasma. The warmth in a room, the slow brightening of morning, the energy stored in leaves, each one traces back to protons that spent ages bumping and failing, until the universe's secret door opened for a moment. The core doesn't need theatrics or crocodile dung sunscreen-level hacks to make a miracle. It needs probability, pressure, and time. And time is exactly what it has. The sun shines because its deepest power is paced by the rules themselves. It doesn't scream its strength. It repeats it, softly, steadily, until that repetition becomes the most familiar light in your life. That steady repetition, rare successes multiplied by endless tries, keeps humming along, and every so often, as if the core exhales without anyone noticing, something slips out that doesn't care about the crowd, the pressure, or the slow traffic of light. It doesn't get trapped. It doesn't bounce around politely. It doesn't queue up behind 1,000 re-emissions like a photon trying to leave a packed concert. It just leaves. You already felt it brush past in that first fusion step. A neutrino, the sun's quietest messenger, the most stubborn little whisper of the core's business, moving through everything like it's late for nothing and afraid of no wall. If photons are the sun's famous face, bright, warm, dramatic in the sky, neutrinos are the sun's private diary entries. They're born deep where fusion happens, and then they go straight out. Not straight out like taking the elevator. Straight out like phasing through the building, because solid matter is, to a neutrino, more of a suggestion than a barrier. You float beside one for a moment, because imagination has privileges physics doesn't, and it's strangely relaxing to ride with something that refuses to be delayed. The neutrino is almost massless, almost invisible, almost indifferent. It carries energy, yes, but it carries it in a way that's hard to steal. It interacts through the weak nuclear force, which is the universe's version of being socially distant by default. Most particles, electrons, protons, can't stop interacting. They bump, they repel, they stick, they light up detectors with enthusiasm. Neutrinos don't do enthusiasm. They do subtle. They move through the dense core plasma where everything is packed and colliding, and they barely notice. It's like watching a person walk calmly through a crowded hallway while everyone else is bumping shoulders and spilling their coffee. And somehow their shirt stays perfectly clean. Annoying? A little. Also deeply impressive. And it's comforting because neutrinos offer a kind of certainty the photons can't. Photons are born in the core too, but they get trapped in the crowd. They're absorbed, re-emitted, scattered, randomized. Their original news gets blurred into a general warmth by the time they reach the surface. That's not a flaw. It's part of how the sun smooths its energy into something steady. But it means sunlight is not a direct, immediate message from a core. It's more like a long story retold by thousands of narrators until it becomes a legend. Neutrinos, on the other hand, are straight from the source. They are core gossip delivered without edits, without delay, without anyone stopping them in the hallway to ask if they've tried crocodile dung sunscreen for their glow. They leave the core at nearly the speed of light, cut through the sun's layers like they're walking through fog, and reach space essentially as quickly as physics allows. So the sun's core is not sealed. It's hidden, yes, dense, bright, unreachable, but it isn't silent. It speaks in neutrinos constantly. Right now, while you're listening, enormous numbers of neutrinos are streaming through Earth, through the roof, through your walls, through your body, through your closed eyelids. They don't care if you're awake, asleep, stressed, calm, mid-dream, mid-snack. They pass through with quiet indifference, like a cosmic breeze you can't feel. That thought can either freak you out or soothe you, depending on your mood. Tonight, it's soothing, because it means the universe is full of things that happen without demanding your attention. The sun's core is working, neutrinos are leaving, and your life doesn't need to manage it. You can be small and still be included. Neutrinos are also weirdly humble as evidence. For a long time, humans suspected the sun's core must be doing nuclear fusion because the sun has been shining for too long to be powered by ordinary burning, and gravitational squeezing alone couldn't keep it bright for billions of years. Fusion was the answer that fit the patience of starlight. But science likes receipts. Neutrinos are the receipts. When detectors were built to catch them, massive tanks of fluid buried underground to escape the noise of other particles, it turned out the sun seemed to be sending fewer neutrinos than expected. Not none, just fewer. The kind of result that makes scientists stare at the data and then stare at the ceiling and then stare at the data again, hoping the universe will apologize and correct itself. It didn't. The universe never does apologies. That mystery became a slow-burning story of its own. This solar neutrino problem wasn't a crisis in the way people like to sensationalize, but it was a genuine puzzle. Was our understanding of the sun wrong, or our understanding of neutrinos wrong, or were the detectors missing something subtle? The relaxing part of that story is how patient it had to be. No one could just check the sun's core. No one could poke it with a thermometer. The core is inaccessible in the way mountains are inaccessible to ants. The answer had to come from careful measurements and stubborn curiosity, the kind that doesn't panic when reality doesn't match the first draft. And the solution was strangely beautiful. Neutrinos change. They come in different flavors, which is one of the most misleadingly cute words in physics, like someone tried to make quantum weirdness sound like ice cream. A neutrino could be associated with an electron, a muon, or a tau, three categories that matter in the math of particle interactions. The point is, neutrinos can oscillate between these flavors as they travel. They can leave the sun as one kind and arrive at Earth as another. If your brain prefers a softer image, picture a neutrino as a note played on a quiet instrument that slowly shifts its tone while sustaining the same gentle sound. Same note, different color. Same traveler, different outfit. No drama, No outfit change montage, just a gradual morphing written into the rules. Early detectors were mainly tuned to catch one flavor. So the sun wasn't missing neutrinos. The neutrinos were simply arriving in forms the instruments were less sensitive to. The core had been telling the truth the whole time. Humans just needed to learn how to listen with better ears. That's a satisfying kind of resolution. The sun stays steady, physics stays consistent, and the mystery comes from the fact that nature is more subtle than our first guesses. It's the same feeling you get when you realize you were stressing about something because you assumed the worst, and then you finally see the real explanation, and it's calmer than your imagination made it. The neutrinos themselves are still almost comically hard to catch. To detect one, you often need an enormous volume of material and a lot of time, because the vast majority pass through without interacting at all. A neutrino might cross light years of matter and never so much as tap a particle on the shoulder. When it does interact, it's like a rare whisper finally tugging a single thread in a giant tapestry. This difficulty makes neutrinos feel like the sun's secret, and also like a perfect bedtime metaphor. Your own thoughts can be noisy, bright photons bouncing around the inside of your skull, scattering off every worry, every memory, every unfinished task. Neutrinos are the opposite. A clean message that doesn't get tangled. A straight line through the clutter. A reminder that some information can be simple and quiet, even when it comes from a place as intense as the sun's core. You stay with the image of neutrinos leaving the core, and you feel how different that is from everything else inside. The plasma crowd jostles and shares energy. Photons are born and immediately trapped, starting their long, slow, exhausting commute outward. But neutrinos, those little minimalists, refuse the commute. They slip out in seconds, telling the universe, in a language almost no one can hear, that fusion is happening, that the core is steady, that the star is doing what it does. It's also oddly comforting that neutrinos are not dangerous to you. They pass through you because they rarely interact. You're not being hit in any meaningful way. You're being crossed. You're a piece of the scenery, and the neutrinos are just passing through on their way to somewhere else, which is basically the most peaceful relationship you could ask for at this hour. If you let your imagination widen, you can picture neutrinos as the sun's heartbeat leaving its chest. Each one is a tiny pulse of truth. Not warmth, not light. Truth. The kind that doesn't care if anyone is listening. The kind that continues whether you applaud it or not. And because they travel almost unhindered, neutrinos carry freshness. The sunlight you see today began as energy in the core long ago, blurred and delayed by that slow diffusion outward. The neutrinos passing through you right now were born moments ago in the core. They're the closest thing you get to live updates from the sun's deepest interior, arriving quietly, invisibly, with no notification sound. Just a constant stream of whispers crossing your room, your bed, your breathing. You can sink into that thought. The sun's core is not only powerful, it's communicative. It leaks truth faster than it leaks light. It sends out messengers that ignore walls, ignore density, ignore the drama of the outer layers. And in the next part of this gentle descent, the contrast becomes even more hypnotic because the energy that becomes sunlight does the opposite of those neutrinos. It takes the slowest, most wandering path imaginable, as if the universe decided to stretch one simple message into the longest bedtime story ever told. Those neutrinos keep slipping out with that smug, minimalist confidence, like they've mastered the art of leaving a crowded room without saying goodbye to anyone. And you can't even be mad at them, because honestly, that's a life skill. But they also make the photons look a little tragic, not in a melodramatic way, more in a slow, quietly hilarious way, like watching someone try to exit a packed theater row while everyone keeps asking them questions about their weekend. Because the energy that becomes sunlight is born in the core too, right alongside those neutrinos. The difference is that light is social. Light interacts. Light can't resist. A photon is basically the opposite of a neutrino, eager to bump into everything, eager to be absorbed, eager to be re-emitted, eager to be redirected, eager to get involved in the world's business. It's the friend who can't walk past a conversation without joining it. So picture a photon's birth deep in the core, where fusion has just released energy. At first, that energy shows up as very high-energy radiation, sharp, intense, far beyond the warm, friendly daylight you think of. It's not yellow sunshine yet. It's more like a blunt, punchy packet of energy that immediately runs into a crowd of charged particles and gets swallowed. And that's the first calming truth about the sun's interior. Light doesn't travel like it travels in space. In space, a photon is free. It runs straight for 8 minutes and then taps Earth on the forehead. In the sun, a photon gets maybe a tiny step, sometimes less than you'd expect, before it's absorbed by an electron or scattered by something charged and forced to change direction. Sometimes it disappears into the crowd and reappears as a new photon with a slightly different energy, like the universe is playing a never-ending game of pass the parcel. Except the parcel keeps being opened and rewrapped in new paper. This is the long, lazy commute. Not lazy because anything is slowed down here. Particles are frantic, collisions are constant. But lazy because progress is reluctant. Progress is messy. A photon doesn't get to choose a straight line. It gets bounced around in a random walk, the way a sleepy person wanders through a dark house, forgetting why they stood up in the first place. If you want the feel of it without getting lost in math, imagine the sun's interior as a fog so thick that even your flashlight beam can't cut through. You shine it, and the light hits tiny droplets, scattering in every direction. In a thick enough fog, the beam doesn't go forward. It goes everywhere. It turns into a glowing blur. That's what the sun does to its own photons, except the fog is plasma, dense and charged, and the interactions are relentless. So the photon takes a step. It gets absorbed. Energy transfers into the plasma, into the motion of particles, into heat, into that restless, crowded equilibrium you've been feeling. Then energy comes back out as a photon again, but not necessarily the same photon and not necessarily in the same direction. The plasma doesn't hand back the energy like a neat return policy. It shares it. It redistributes it. It smooths it out. That smoothing is almost tender. A sharp, high-energy photon is like a sudden loud noise in a quiet room. The core doesn't tolerate loud noises for long. It breaks the energy into smaller portions through countless interactions. Over time, what begins as something fierce becomes something gentler, softer, more compatible with a star that wants to last. The sun's interior is basically the universe's most patient sound engineer, steadily lowering the harsh frequencies until the final track is something you can actually live under. And over time, is doing a lot of work there. Because the next relaxing fact is so absurd it's funny. The sunlight that warms your face was not necessarily made this morning. The neutrinos arriving through your bedroom are fresh, practically live from the core. But the photons that eventually become sunlight can take an unbelievably long time to escape. Not 8 minutes, not a day, more like an immense stretch, often described as thousands of years, sometimes far longer depending on exactly how you define the process and where you start counting. The point isn't the exact number. The point is the vibe. The sun is running on delayed delivery. So when you feel warmth from sunlight, you're feeling a message that took the scenic route. The most scenic route. The route where you stop in every village, talk to every stranger, and somehow end up at your destination decades late with souvenirs you don't remember buying. Photons are the tourists of the sun. You can sense how that would be inevitable. The interior is opaque, not because it's dark, but because it's too full. There are so many charged particles that light can't travel far without interacting. It's like trying to sprint through a crowd where everyone wants a hug. You move an inch, get hugged. Move another inch, get hugged again. It sounds sweet until you realize you'll be there forever. This is also why the sun can feel calm from the outside. The energy produced in the core doesn't come rushing out in a burst. It leaks outward slowly, diffusing through layer after layer. The slowness is a safety feature. It's a built-in smoothing filter. It prevents the sun from acting like a flickering candle. It turns nuclear reactions, something that could sound terrifying in your imagination, in a steady daylight, dependable and boring in the best way. And the photon doesn't just wander, it changes. Every absorption and re-emission is a chance for the energy to be shared among many particles, and the re-emitted photon might carry a little less energy than before. Over countless steps, the overall energy distribution shifts toward lower energies. The light becomes less harsh. It becomes more thermal, more like the kind of glow a warm object gives off when it's in equilibrium with itself. It's almost like watching a sharp, intense thought soften into a vague, comfortable feeling as you get sleepy. The core starts with something clean and intense. Fusion releases energy in a way that's precise and high energy, and the sun's interior turns it into something you can live under, something that doesn't stab your senses. By the time the energy nears the regions where light can finally begin to travel more freely, it's already been rewritten into a gentler language. If the sun had a personality, photons would be its long, rambling storytellers. Neutrinos are the short text. Fusion happened. But photons are the 3-hour voice note where the main point is buried somewhere around minute 90, but you're weirdly comforted by the sound of it anyway. And you can't blame the photon for taking so long, because it has no map. Every interaction resets its direction. Forward, backward, sideways, it's all the same. The photon is constantly being told where to go by the plasma around it. It's like being carried in a crowd rather than walking under your own power. This random walk has a gentle lesson in it. You don't need a straight line to make progress. The photon proves it. It proves you can take a messy path, get interrupted a million times, lose your original sharpness, and still eventually become something useful. Something that warms a planet, grows forests, powers ocean winds, and lights up someone's window while they're trying to fall asleep. Even the scale of the sun's interior helps that metaphor land without trying too hard. The core is only a fraction of the sun's radius, but it's the main place where energy is created. The photon's job is to get that energy out. But it's not job like a to-do list, it's job like a natural consequence. Energy will move from where there is more of it to where there is less, because the universe loves balancing acts. The photon doesn't need motivation. It just gets shuffled outward by endless interactions, like a leaf being carried downstream by a current it never sees. Sometimes the photon's journey feels like an exaggerated version of your own mind at bedtime. You try to settle into one thought, calm, steady, warm, and then something interrupts. A memory, a worry, a random thought about whether anyone ever actually tested crocodile dung sunscreen, or whether that was just an ancient prank that got out of hand. Your mind bounces. The photon bounces. The difference is the photon doesn't judge itself for bouncing. It just keeps going. Another quiet detail. Inside the sun, photons aren't really traveling as light in the way your eyes understand. They are constantly being absorbed and re-emitted, which means the energy spends a lot of time not as a photon at all, but as the motion of particles heat. The sun's interior is like an energy bank where deposits and withdrawals happen endlessly. The photon is just one form the energy takes for part of the trip. Much of the time, the energy is in the jostling plasma itself, stored in the speed of particles, shared and reshared until it finds another moment to pop back out as radiation. That helps explain why the core can be so hot without looking like a blinding spotlight from within. The energy is everywhere, tangled in matter, not traveling cleanly. The glow you see as the sun is what happens when the energy finally reaches a region where it can radiate away, where photons can stream freely into space and stop being constantly intercepted by the crowd. But you're not there yet. You're still in the deep interior, feeling the patience of it. You feel how the sun is built to be slow, built to be steady, built to take an absurdly long time to turn core energy into surface light. Because a star that does anything quickly is a star that doesn't last. So while neutrinos race outward like secrets that can't be contained, photons take the role of slow comfort. They're the reason sunlight is reliable rather than explosive. They're the reason the sun feels like a constant presence instead of a flickering hazard. They're the reason you can plan a life around day and night without thinking too hard about the nuclear reactions happening far beneath the bright surface. And as you keep following that wandering, softening energy, absorbed, re-emitted, redirected, diluted into gentler forms, you start to feel the deeper symmetry. Gravity holds the core steady. Fusion releases energy in small, paced amounts. Neutrinos whisper the truth immediately, and photons carry the warmth outward with the patience of geological time. Until one day, long after its first chaotic steps in the core, it escapes into space and finds your world. That photon, finally slipping into freedom in your imagination, makes the sun feel generous, like it's constantly handing out warmth without keeping score. The calmer truth sits underneath. The sun isn't generous so much as balanced. It doesn't decide to shine steadily. It's held in a quiet compromise so stable it can outlast every single thing you've ever overthought at 2 a.m. You can feel the compromise as two faithful pressures meeting in the middle. Gravity presses inward, heavy and patient. Heat and motion press outward, just as patient, just as relentless. Neither side wins. Neither side throws a fit. They settle into a truce that looks, from the outside, like a bright circle that shows up every morning as if it signed a contract with your calendar and never missed a date. This truce has a name that sounds like it wears a lab coat: hydrostatic equilibrium. Don't let the syllables intimidate you. It simply means that at every depth inside the sun, the inward pull of gravity is matched by an outward change in pressure. Not one big shove from the center like a balloon trying to pop, but a layered support system. Every region helping hold up the regions above it, like an endless stack of cushions that somehow never collapses. Picture that stack. The outer layers are light by star standards, and they don't have much weight above them. The deeper layers are carrying more and more of the sun overhead. So pressure rises the deeper you go, not as a mood, but as a consequence. The core feels so contained because it's supporting almost the entire sun above it. It's not trying harder. It simply has more on its shoulders. If the sun had a posture coach, gravity would be the one insisting everything stays compact and aligned, and pretending it's not a control freak. Pressure down here isn't just one simple push either. There's the familiar kind. Particles zipping and colliding, constantly bumping into each other, transferring motion like a crowded room where nobody can keep their elbows to themselves. That's gas pressure, even though gas feels like the wrong word in plasma. Then there's radiation pressure. Photons transferring momentum whenever they're absorbed or scattered. Light isn't only a message, it's also a gentle physical shove. In the sun, even the trapped light contributes to holding the star up, like a million tiny hands pressing outward in slow motion. The strange comfort is that both kinds of pressure come from the same basic idea: motion. Particles moving create pressure. Photons moving create pressure. The core is full of motion, and that motion is what keeps gravity from finishing the squeeze. It's a stalemate made of movement. The most relaxing part of the truce is how it corrects small disturbances without needing anyone to intervene. If a region in the core gets a little warmer, pressure rises. Higher pressure makes that region expand slightly. Expansion lowers density. Lower density means fewer close encounters between nuclei, fewer opportunities for the rare fusion steps. So the fusion rate tends to ease back down. The extra warmth fades. If the core cools a little, pressure falls, gravity squeezes, density rises, collisions become more frequent, fusion nudges up again, and the temperature drifts back towards steady. It's a built-in stabilizer. No panic, no urgent call, no group chat meltdown, just physics quietly doing its job. This is why the sun isn't a flickering candle. A candle lives on a thin edge. Airflow, fuel, a breeze, a sneeze, the universe deciding your lighter is out of fluid. The sun lives inside a thick, self-correcting balance. Gravity presses, pressure answers. The star holds its shape, and the long photon commute you followed is part of that same balance, not just a travel story. Energy made in the core doesn't only matter when it finally escapes as sunlight. It matters while it's still trapped. That energy is constantly being swapped between radiation and the motion of particles, and as long as it's there, it contributes to pressure. It helps support the layers above. The sun is literally held up by the energy it is producing and distributing, even before that energy ever leaves. You can sense how that creates stability. If energy escaped too easily, pressure would drop. With less pressure, gravity would win for a while, contracting the star. Contraction would raise the core temperature and density, increasing fusion until pressure built back up. If energy were trapped too effectively, pressure would build and the star would expand. Expansion would cool the core a bit, fusion would slow, and pressure would relax. The sun is always nudging itself back toward the middle, like a perfectly calm person adjusting their pillow without opening their eyes. Even the sun's size is part of the agreement. There isn't a cosmic blueprint that says, make the sun exactly this radius. The radius is the outcome of the negotiation between gravity and pressure for this particular mass and makeup. The terms are what they are, and the balance has had a very long time to settle into a steady solution. That steadiness doesn't mean stillness. Stable doesn't mean frozen. It means balanced on average, with constant tiny adjustments that happen so smoothly you wouldn't notice unless you were staring at the sun's behavior with instruments and patience. The interior subtly shifts, redistributing pressure, redistributing energy, keeping gravity and outward support in agreement the way a person shifts in their sleep without fully waking. The sun is always breathing in this quiet way, expanding a hair, contracting a hair, never enough to break the truce, always enough to keep it healthy. There's also something soothing about the fairness of it. Every layer participates. The core doesn't carry everything alone. The outer layers aren't just dead weight. Each region contributes to the overall structure through pressure, density, and the way it transmits energy. The sun is a cooperative system, not because it wants to be, but because physics leaves it no other option. Cooperation is the default when gravity is the boss and pressure is the only answer. Hold the picture as you get sleepier. Two hands meeting in the middle of the sun. One hand is gravity, closing inward, firm and steady. The other hand is pressure, pushing outward, warm and unwavering. They press against each other without shaking, without struggling, without either side needing to win. The sun exists in the space between those hands, a steady sphere shaped by compromise. And that photon you followed, born deep, scattered a million times, softened into something gentler, belongs to the outward hand. Each packet of energy is not only future daylight, it's present support, one more small contribution to the star's ability to hold itself up from within. The sun doesn't hang in space like a lamp on a wire. It keeps its posture by balancing forces everywhere at once. Your breathing can borrow that steadiness for a few quiet minutes. Inward, outward. Pressure, release. Not a fight, a rhythm. Gravity presses in. The core presses out. The truce continues, quiet and unstoppable, while your thoughts loosen their grip and your body remembers it doesn't have to hold the whole world up by itself. That rhythm you're borrowing, inhale, exhale, pressure, release, has an echo inside the sun that's even steadier than your pulse and almost as intimate. You can't hear it with ears because space doesn't carry sound the way air does, and the sun is not politely offering you a microphone-friendly environment. Still, the star is full of vibrations. It quivers. It rings. It hums in patterns that travel through its layers like a lullaby written in physics instead of melody. It's the kind of idea that makes you want to press your ear against the sun like it's a door at a party, listening for gossip. That would be a very short party for you, but the impulse is understandable. Humans love eavesdropping on mysteries. The good news is you don't need to be anywhere near the sun to listen to it. You only need to watch it carefully enough to notice how it moves. The sun's surface isn't still. It shimmers and boils in slow, rolling patterns, like a golden pot that never stops simmering. Some of that movement is convection closer to the surface, those rising and falling flows. But layered on top of that are subtle, global vibrations, waves that pass through the sun and make the surface rise and fall by tiny amounts. Not dramatic, not visible like a wave in the ocean. More like the barely noticeable lift of a sleeping chest. If you've ever watched someone breathe in a dark room, you know how calming it is when the movement is small and regular. The sun does something like that, except it's the size of a star, and the breathing is actually the whole interior ringing like a bell. Those waves matter because they act like a scan. On Earth, when you want to know what's inside something you can't open, your planet, your body, a wall behind drywall, you send waves through it and listen to how they change. Seismology uses earthquakes to learn Earth's interior. Medicine uses ultrasound. The sun, conveniently, generates its own waves all the time. It's constantly tapping itself, gently from the inside out, and the patterns of those taps tell you what the inside is like. This is helioseismology, which sounds like the name of a fancy espresso drink, but it's really the art of reading the sun's vibrations. You watch the surface carefully, measure tiny shifts, and from those shifts you infer what's happening deep below. You're basically listening to a star's heartbeat by watching its skin move. The relaxing part is how indirect it is. You never need to break the sun open or disturb it. You don't even need the sun to cooperate. It's already vibrating. It can't help it. Pressure waves form as the interior churns, and those waves bounce around inside, reflecting and refracting through different layers. Each layer has its own density, temperature, and composition, and that changes how waves travel, how fast they move, how they bend, how they stand in place to form patterns. Think of a musical instrument, but make it absurdly huge. A guitar string has certain notes it prefers because of its length and tension. A drum's skin vibrates in patterns. The sun has preferred vibration modes too, shaped by its size and internal structure. These modes overlap and interfere, creating a rich spectrum of patterns. It's not a single note. It's a whole chord, held for years, constantly refreshed by the sun's internal motion. If you could translate those vibrations into sound, the sun would be singing in frequencies too low for your ears. Deep, slow notes, the kind that feel more like a vibration in your chest than a tone. It's like bass you don't hear so much as notice. But even without translating into audio, the pattern is meaningful. The wave speeds tell you about temperature and density. The way waves are deflected tells you about layers. The way certain modes shift over time tells you about changes in the interior. And this is the part that should soothe you. The sun's core, hidden and unreachable, leaves fingerprints on the surface through these waves. That means the deepest region isn't completely locked away. It influences the stars, music, and careful listeners can reconstruct a map of what's inside. You've been drifting in the core, feeling the pressure balance, the plasma crowd, the slow fusion rhythm, the neutrinos slipping away, the photons wandering outward. Helioseismology ties it together like a quiet confirmation. Yes, the interior behaves the way it should. Yes, the star is stable. Yes, the core is doing what physics predicts, and you can see the evidence without ever getting close enough to regret your life choices. Waves in the sun don't just travel randomly. Some are like sound waves, pressure waves, rippling through the interior. Others behave differently, guided by buoyancy and density gradients. They bounce between layers, like whispers in a long hallway that keep reflecting off walls until the whole corridor feels alive. When those waves reach the surface, they make it subtly rise and fall, creating a pattern of motion that can be measured by watching how sunlight shifts in frequency. Tiny Doppler changes, like the sun is gently moving toward and away from you as it breathes. That's what scientists do. They watch the sun's surface with insane patience and precision, measuring those minute shifts. It sounds tedious, but it's also kind of poetic. Instead of forcing information out of the universe, you observe it. You let the sun tell you what it is by being itself. If your brain wants something concrete, picture a calm pool. Drop a pebble in the center, and ripples move outward. Now, imagine the pool isn't just water. It has layers of different thickness, different density. Those ripples change shape as they pass through. They speed up in some regions, slow down in others, bend, and reflect. If you only watch the surface, you could still infer what the hidden layers were like because the ripples reveal them. The sun is like that layered pool, except the ripples are happening constantly, and the pebbles are all the small disturbances created by the sun's own internal motion. Convection near the surface, turbulence, subtle pressure changes. The waves travel, meet, form standing patterns, and the surface becomes a living record of the interior. And it's not just structure. The sun rotates, and it doesn't rotate like a solid ball. Different latitudes spin at different speeds near the surface, and the interior has its own rotation profile. The waves feel that rotation as they travel. Rotation changes their frequencies and splits modes, like a spinning bell producing slightly different tones, depending on how it's moving. By decoding those splits, you can infer how different layers rotate, including deep regions that no telescope can see. That's one of the best sleepy facts. The sun is transparent to its own vibrations in a way it isn't transparent to light. Like it's trapped and scrambled. Waves carry information about structure in a more direct way, because their travel depends on the medium itself. The sun hides its core from your eyes, but it can't hide it from its own ringing. There's gentle sarcasm tucked in here, too, because the universe loves doing things the hard way for humans. It's like the sun is saying, "You want to know what I'm like inside? Fine, solve my riddle. I will vibrate in tiny patterns you can barely measure, and you can reconstruct my interior like a cosmic detective story. Good luck." And humans, stubborn as ever, went, "Okay." This detective story becomes a comfort story at night because it replaces fear with familiarity. The sun's core isn't a chaotic mystery box that could suddenly do something outrageous. The waves say the sun is stable. The modes say the structure is consistent. The patterns match a star held in a long truce between gravity and pressure. Helioseismology is like placing a hand on the star's chest and feeling a steady, reliable rhythm. If you let your mind drift with that, you can almost feel the sun as a giant instrument. Not loud, not showy, just resonant. The whole star is a cavity for waves, a vast space where vibrations can travel and reflect, creating patterns that persist. The core is the deep chamber where the conditions are most extreme, and the waves that pass through it carry the signature of that extremity in their timing. Faster here, slower there. Slightly altered by density, temperature, composition. The sun's interior becomes a score, and the surface is where the notes become visible. And this is where your earlier images line up in a satisfying way. The core's steady fusion acts like a deep engine, producing energy. Gravity keeps everything hugged inward. Pressure pushes outward. Photons wander slowly. Neutrinos flee instantly. Waves ripple through all of it, carrying information like a quiet soundtrack. It's not chaos. It's layered order, different forms of motion doing different jobs. Even the idea of soundless music is comforting because it reminds you that there are patterns you don't have to force. Your mind can let go and still be surrounded by structure. The sun has structure. It has rhythms. It has modes. It has a steady internal pulse that doesn't care if you're listening, but becomes more calming when you realize it's there. There's also something humbling and soothing about how small the surface motions are compared to what they represent. The sun's interior is intense beyond comprehension, yet its global oscillations show up as tiny surface shifts. Big causes can have subtle signs. That's true in physics, and it's also true in a sleepy brain. A small tension in your jaw can mean a whole day's stress got stored there. A tiny shift in breath can mean you're finally relaxing. The sun's tiny surface ripples mean the star is ringing. And from that ringing, you can read the hidden interior like a bedtime story written in waveforms. You stay with the image of the sun as a resonant sphere, holding its own rhythm in the dark while your planet turns. The photons that will become daylight are still meandering outward somewhere in those layers, taking their ridiculous scenic route. Neutrinos are already gone, whispering the present moment of fusion into the universe. And the vibrations continue, traveling through layers, echoing off boundaries, making the star subtly rise and fall like a sleeping giant. From here, the mystery deepens without getting louder, because once you accept that the sun can be mapped by its own waves, you start to realize how much can be learned without touching, without opening, without invading. The core remains hidden, but not unknowable. The sun can be listened to with patience, and patience is exactly the pace your body likes right now. Those quiet vibrations keep moving through the sun like a private soundtrack, and the more you sit with them, the more you start to feel what they're really measuring. Not just motion, not just temperature, something simpler and more intimate. What the sun is made of, right down in the core, where nothing gets to pretend it's a tiny little atom with a neat electron halo. Because that's the thing about waves. Whether they ripple through a guitar string or a star, they care about the medium. They care about how heavy the particles are, how tightly packed they are, how easily the whole crowd responds when pressure nudges it. It's almost like the sun is revealing its ingredients through the way it rings, as if the core can't help humming the name of everything inside it. And what's inside is almost offensively simple. You've met the plasma crowd already. Nuclei and electrons moving separately. No stable atoms, no chemistry the way you know it. But if you zoom in on the cast of characters, it's basically the universe showing up with the same two main ingredients it uses everywhere and saying, with a straight face, this is enough. Most of the core is hydrogen and helium. Not hydrogen as a gas with cute little H2 molecules floating around like balloons. None of that survives here. Hydrogen in the core is mostly bare protons, stripped clean, racing and colliding. Helium is helium nuclei, heavier and calmer in their own way, carrying two protons and usually two neutrons, moving through the same charged ocean with electrons constantly swarming around to keep things overall neutral. The electrons are everywhere too, light and quick, responding instantly to forces, smoothing out charge imbalances before they become anything dramatic. The core isn't full of atoms so much as it's full of parts, protons, helium nuclei, a sprinkle of other nuclei, and a sea of electrons making the whole thing behave like one dense, responsive fluid. It's easy to picture the sun as a perfect ball of mostly hydrogen, and that's true in a broad, polite sense. But the core has been working for billions of years, and work leaves traces. Fusion doesn't just release energy, it changes the mix. The core is a kitchen that never closes, and the recipe is slowly shifting even though the chef never panics. At the sun's birth, the material was more uniformly mixed. Lots of hydrogen, a good amount of helium, and a small fraction of everything heavier than helium. What astronomers casually call metals, which is hilarious, because in their world oxygen counts as a metal, and if you bring that up at a dinner party, you will not be invited back. Those metals are still a small fraction of the sun's overall mass. Most of the sun is still hydrogen and helium, because the universe is basically obsessed with those two. But the core's chemistry has a subtle gradient now. In the very center, hydrogen has been slowly turned into helium over time. That means the helium fraction is higher in the center than it was long ago, and hydrogen is correspondingly lower there. It's not a sudden switch. It's not like the core woke up one morning and announced, hydrogen is canceled. It's a slow drift, almost sleepy in its patience. The sun can afford to change its recipe because it changes it at a pace that makes mountains look impulsive. And the really calming part is that, even with billions of years of fusion, the core hasn't become some exotic stew of weird elements. It's still mostly the simplest things. Helium ash accumulates, yes, but it's still helium, still one of the universe's favorite basics. The core remains familiar in its ingredients even as it evolves in its proportions. There are also trace players that matter more than their tiny numbers suggest. Carbon, nitrogen, and oxygen, C, N, O, exist in small amounts, and in a star like the Sun they act like quiet helpers. The Sun primarily runs on the proton chain, that slow, probability-driven process you followed, paced by the weak interaction like the universe insisting everyone walk, not sprint. But there's also another pathway for hydrogen to become helium, the CNO cycle, where carbon, nitrogen, and oxygen nuclei act like catalysts. They aren't consumed in the net reaction. They help the process happen and end up restored at the end, like a set of stepping stones that keep getting reused. In the Sun, this pathway is a minor contributor compared to the main proton routine, but it's still there, quietly doing work when conditions allow. That's one of those gentle cosmic jokes. A star can use a tiny sprinkle of heavier elements to assist in turning the most common element into the second most common element. Big results from small helpers. The universe loves that. Those heavier elements also matter because they affect how easily radiation moves through the plasma. Even in a core dominated by hydrogen and helium, the metallicity influences opacity, the tendency of the material to absorb and scatter photons. You've already felt how photons get stuck, how the energy takes the long commute outward. The exact ease or difficulty of that commute depends on the composition. A small fraction of heavier nuclei can make the interior more opaque, making photons even more inclined to bounce and scatter, which affect how energy is transported and how temperature gradients settle. So the core's chemistry isn't just trivia. It's structure. It's the reason the Sun's internal music sounds the way it does, because wave speed depends on density and temperature and the average mass of the particles sharing the pressure. It's the reason the star's energy takes its slow journey outward in the particular way it does. It's the reason the truce between gravity and pressure stays so smooth. And still, even with these details, the overall vibe remains simple. Hydrogen and helium are the main story, with a light dusting of everything else like seasoning. If the Sun were a recipe, it would be suspiciously minimalist, the kind you scroll past online because you're convinced it can't taste good with only 3 ingredients, until you remember it's powering an entire biosphere without even trying. The core's chemistry also helps explain why it stays calm instead of mixing itself into chaos. The region where the Sun generates most of its energy is deep enough that energy transport is primarily by radiation rather than convection. In plain language, it doesn't boil and stir itself like a pot of soup down here. Without that constant stirring, the core develops a gentle stratification. Helium produced by fusion tends to stay where it's made, building up over time in the center. Hydrogen from farther out doesn't rush in to replace it in a dramatic swirl. The Sun isn't aggressively mixing its deepest interior. It's letting the changes accumulate slowly, layer by layer. That's why the core has this loyal ingredients feeling. It's not a blender. It's more like a slow cooker. The recipe changes, but it changes with calm continuity. The ingredients remain recognizable, and the system stays stable. Even the electrons, the restless sea you've been floating through, reflect this simplicity. Every nucleus carries positive charge. Electrons provide the negative charge that keeps everything neutral overall. Their presence also matters for pressure, because electrons contribute to the gas pressure along with ions, and their fast movement helps the plasma respond smoothly to disturbances. Later, Much later in the sun's life, electrons will matter in other ways too. But here and now, they're part of the everyday support structure, light quick everywhere, enforcing balance without fanfare. It's a little like the quiet role of good infrastructure in your life. You don't think about plumbing until it doesn't work. You don't think about the wiring until something flickers. The core's electrons are the wiring. Always there, always responding, making sure the system behaves like a coherent whole. If you let your mind rest on the proportions without clinging to exact numbers, you can still feel the direction. The center has more helium than it used to because it's been making helium. It has less hydrogen than it used to because hydrogen is the raw material. The metals remain a small fraction, but they quietly influence how energy moves and how the plasma interacts with radiation. Carbon, nitrogen, and oxygen are present as trace catalysts and structural seasoning. Everything is stripped to nuclei and electrons. No molecules, no stuff in the familiar sense. Just fundamental particles and forces doing the same routines over and over in a crowded, disciplined environment. And because the changes are slow and layered, the core doesn't feel like it's racing towards something. It feels like it's keeping a steady pace, adjusting the recipe gradually, almost politely, as if it's aware that a star that rushes is a star that doesn't last. There's a comforting humility in that. The sun doesn't need complexity to be magnificent. It doesn't need exotic elements in abundance. It doesn't need flashy chemistry. It's mostly hydrogen and helium, with a few supporting actors, and that's enough to light the world, drive winds, warm oceans, and send those neutrino whispers through your room without anyone hearing them. Your brain can relax into the simplicity. No need for complicated metaphors. No need to turn it into a fantasy forge. It's a dense plasma made mostly of the universe's simplest nuclei, slowly shifting its proportions as it works, staying stable because it's not being violently stirred, and because gravity and pressure keep the whole system in a calm agreement. That calm agreement is still humming under everything. The waves, the photons, the neutrinos. And the more you understand the ingredients, the more you can feel the next quiet mystery forming. How that slow shift in the core's mix becomes its sense of time, its internal clock, ticking so slowly that the future unfolds like a dream you don't have to force. That sense of time in the core isn't a ticking clock you can hear. It's more like a slow change in the air of a room you've lived in for years. So gradual, you only notice it when you look back and realize the light feels different than it used to. The sun's core keeps time with chemistry and pressure and patience. It marks its hours not in seconds, but in how many protons have quietly stopped being protons. You can feel the core's clock in the way fusion is paced. That first step in the proton chain, the moment one proton becomes a neutron, moves at a speed that's almost comedic when you compare it to human impatience. It's governed by the weak nuclear force, which is basically nature's way of saying, absolutely not in a rush. That slowness is the reason the sun's core is calm. It's the reason this star can keep doing the same thing for billions of years without turning into an exhausted ember that burned too fast. And that slowness creates something soothing, a guarantee of continuity. You don't need to fear the sun deciding to run out overnight. The core is a long game, and it plays it with ridiculous commitment. Still, the clock is moving. Every successful fusion chain leaves behind helium. Not helium floating around like party balloons, helium nuclei, heavier and more tightly bound, gradually accumulating in the very center where they're made. It's like a quiet snowfall of helium ash, except the snowflakes are atomic nuclei and the blizzard lasts for eons. This accumulation changes the core in a subtle but important way. It changes what average means. Helium nuclei are heavier than protons. As the helium fraction rises in the center, the average particle mass and the way pressure responds begin to shift. The core doesn't become unstable, but it does evolve. It's like the same song played on a slightly different instrument. Still the same melody, but the tone deepens over time. As the core becomes more helium-rich, It has to adjust to keep supporting the sun against gravity. Pressure still has to match the inward pull. If the core has fewer hydrogen nuclei available per unit mass and more helium, the details of how pressure is maintained change. The cores slowly contract a little to keep up. Contraction raises temperature and density. That increases the pace of fusion. Not dramatically, not like a sudden sprint, more like the smallest increase in breathing rate when you climb a gentle hill. This is one of those quiet, almost sneaky truths. The sun's core doesn't stay at exactly the same temperature forever. Over time, it slowly gets hotter. The sun also slowly becomes more luminous as it ages on the main sequence. From the outside, it still looks like the sun, bright, steady, familiar. But the core is gradually turning the dial, millimeter by millimeter, because composition is changing and gravity's hug never stops asking for support. The core's clock, then, is a feedback loop stretched across geological time. Hydrogen becomes helium. Helium changes the core's properties. The core contracts slightly. Contraction raises temperature. Higher temperature increases fusion rate. More fusion produces more helium. The cycle continues, controlled and stable, because every step is slow and self-correcting. If your mind likes a clean image, picture a sand timer so large that one grain falls every few years. You would never sit and watch it for the moment it changes, because there's no moment. There's only gradual change. That's the core. The sun isn't flipping pages. It's rewriting a sentence one letter at a time. And because you're a listener with a human brain, you want to know where the timer ends. It ends when the core runs out of hydrogen that's easy to fuse in the center. Not all hydrogen in the whole sun, because there's plenty of hydrogen elsewhere, but hydrogen in the core region where the temperature and density are high enough for fusion to keep going in its current steady style. This is another calm, understated fact. The sun's core has boundaries that matter. The whole sun is huge, but only the inner region is hot and dense enough to run fusion efficiently. Outside that region, conditions are different. So the sun's fuel supply, in practical terms, is limited by the conditions where fusion happens, not by the total amount of hydrogen in the entire star. Over billions of years, the central hydrogen fraction steadily drops. The helium fraction steadily rises. The core's density and temperature steadily increase. And the luminosity of the sun slowly increases as the fusion rate creeps upward in response to those changes. This happens so slowly that life on Earth experiences it as an almost invisible trend across deep time, not as a dramatic shift from one day to the next. The sun's core is, again, allergic to drama. It's also comforting that the core is stable because it can't change quickly. Even if, in some hypothetical sense, you tried to poke the core, you would be dealing with a system where the relevant timescales are enormous. Energy transport is slow. Structural adjustments propagate through the star with wave speeds and thermal diffusion that take their time. The sun has inertia, not just mass inertia, but thermal inertia. It doesn't respond to small changes by doing anything impulsive. It responds by slowly, smoothly drifting back toward equilibrium. That's why the sun has been reliable across human history and across the much longer story of life. The core's clock is measured in billions of years. Human life is measured in decades if you're lucky and reasonably hydrated. Your worries live on a timescale that the sun barely notices. If you let that thought land gently, it doesn't belittle your life. It softens it. It makes your stress feel less permanent. The sun's core has been turning hydrogen into helium since before there were continents with familiar shapes. It will keep doing it long after your current inbox problem becomes an archaeological curiosity. That kind of scale doesn't fix your problems, but it loosens the tightness your mind puts around them. The core's clock is also written into the neutrinos you rode with earlier. Neutrino production is directly tied to fusion. As the sun's core slowly changes, the details of neutrino output shift too. Not in a way you'd notice without detectors the size of buildings, but in principle The neutrinos are a live whisper, not just of fusion is happening, but of the core's evolving conditions. They're the present tense of a process that unfolds over eternity. And the photons, those poor, wandering tourists, add another layer of time to the story. The energy created in the core is delivered to the surface on a delay. That means the sunlight you receive is not an immediate reflection of what the core did this morning. It's the end of a long chain of interactions. The core's clock is slow, but the sun also has a kind of built-in buffering. Changes in the core take time to show up at the surface as changes in light output, because energy transport is not a direct pipeline. The sun is patient even in how it reveals itself. So even when the core gradually changes, the star's outward behavior remains smooth. No sudden flickers, no sudden starvation of light. The sun's evolution is like a slow fade in a film, not a jump cut. If you want a simple way to feel the sun's remaining patience without drowning in numbers, think of it like this. The sun is roughly middle-aged by star standards. It has spent billions of years in this stable phase and has billions of years still ahead before the deepest rules change. That stable phase, where hydrogen fusion in the core provides the outward pressure to balance gravity, is the long, calm middle of a star's life. The beginning is formation and settling. The end is transformation into something new. The middle is steady daylight for unimaginably long spans. In this middle phase, the core's destiny is to become more helium-rich until the conditions no longer support the same kind of hydrogen fusion in the center. When that happens, the core will change character. Hydrogen fusion shifts outward into a shell around the helium core, and the star's structure responds in bigger ways. But that's a future the core approaches the way it approaches everything, gradually, with no theatrics, as the slow clock continues to tick. There's a subtle grandeur in that approach. The sun isn't a fragile object waiting to fail. It's a system designed by physics to evolve predictably. The same rules that make fusion rare and steady also make the timeline long. The same gravity that hugs the core also ensures that any changes are controlled by equilibrium, not by chaos. So the core's clock is simple, and that's what makes it relaxing. It ticks with helium. It ticks with density. It ticks with tiny adjustments that keep gravity and pressure in balance. It ticks with a slow increase in temperature and luminosity, so gradual that nothing in your short life needs to fear it. It ticks in neutrinos that whisper out immediately and photons that wander out over ages, two kinds of time layered over each other. You stay with that layered time. Instant whispers and ancient sunlight, slow chemistry and steady structure, and it starts to feel like the core is less a place and more a pace. A pace that doesn't rush, doesn't panic, doesn't catastrophize. The core just keeps the rhythm, and the rhythm keeps the sun. That sense of time in the core, the slow clock made of helium and patience, can trick your mind into thinking the center must be responsible for every dramatic thing the sun ever does. You see a flare in a clip, a sunspot big enough to make people gasp, and your brain points straight to the middle like it just solved a mystery. The core, being hidden, gets blamed for free. But the sun is layered, and it keeps most of its chaos closer to the surface. The way some people keep their emotional mess stuffed in a closet with the door half closed and pretends it isn't there. Deep down, the core stays calm. Not calm as in nothing moves. It's still a dense ocean of plasma where particles never stop colliding and sharing energy. Calm, as in no sudden mood swings. The core is basically the quiet roommate who pays rent on time and never turns the living room into a bonfire. The magnetic drama, the bright loops, the eruptions, the flares that can fling charged particles outward, mostly starts elsewhere, in layers where the sun is allowed to be messy. Two kinds of busy exist in the same star. The core is busy in a steady, statistical way. Fusion paced by probability, pressure balancing gravity, energy diffusing outward like a story told slowly on purpose. The outer layers are busy in a theatrical way. Huge flows rising and sinking, twisting and shearing, constantly reorganizing magnetic fields like someone rearranging a closet because they swear it will finally fix their life. It never fixes their life. It just creates piles. The first reason the drama stays higher up is how energy moves. In the deep interior above the core, energy travels outward mostly by radiation, that long photon shuffle you followed earlier. Radiation transport doesn't stir the plasma the way boiling water stirs itself. It doesn't create giant rolling cells that flip and fold the material. It lets that region remain relatively smooth on large scales, stratified and stable, with motion that tends to be subtle rather than turbulent. Farther out, the rules change. There's a vast region where energy transport becomes dominated by convection. Hot plasma rises, cools closer to the surface, sinks again, repeats. The sun becomes a star-sized lava lamp that never switches off. Convection is naturally chaotic in a beautiful way. It creates swirls and eddies. And because the sun's fluid is made of charged particles, those swirls don't just move matter. They move magnetism. A magnetic field in plasma isn't a set of decorative lines on a diagram. It behaves more like threads woven into a moving fabric. Plasma and magnetic fields are coupled. When the plasma flows, it drags the field with it, stretches it, twists it, folds it. A gentle flow becomes a gentle tug on those threads. A complicated flow becomes a braid. A braid becomes a knot, and knots store energy. That stored magnetic energy can sit quietly, like tension in a twisted rubber band. The sun can look perfectly normal while the field is getting more and more tangled in the background. Then, when the field lines snap into a new configuration, less twisted, more orderly, the tension is released. The released energy shows up as heat, light, and fast particles. That's a flare. Not the core suddenly changing its mind, but the outer layers releasing a backlog of magnetic stress. Rotation adds the next layer of mischief. The sun doesn't rotate like a solid ball. Near the surface, the equator spins faster than the poles, and different depths can rotate differently too. This is differential rotation, and it's basically the sun doing a slow, endless ringing motion. If you take a magnetic field and shear it, stretch one part ahead of another, you amplify and reorganize it. You wind it tighter. You turn a modest field into bands and loops. And those structures can rise through the convective layers and poke through the surface as arches and glowing ropes. Deep inside, the story is less ring-y. The region beneath the convection zone tends to rotate more uniformly compared with the surface layers. The details are inferred from that soundless music of the sun's vibrations, but the feeling is consistent. The deep interior changes slowly with huge inertia. It doesn't churn like the convective zone. It doesn't constantly twist magnetic fields into tight knots that demand immediate release. Between the calmer radiative interior and the turbulent convective region sits a thin transition layer where the rotation behavior changes. It has a name, the tachocline, and it earns that attention because it's a zone of strong shear. Shear is excellent at taking existing magnetic fields and stretching them into stronger, more organized structures. It's one of the places the sun's magnetic engine gets its grip like a hand catching a rope and pulling it taut. That magnetic engine is the solar dynamo, the process that generates and maintains the sun's large-scale magnetic field. It's not a machine with gears. It's the outcome of plasma motion plus rotation plus magnetic coupling. Convection twists and lifts. Differential rotation stretches and winds. The field strengthens, changes shape, and cycles through patterns over years. You see the cycle at the surface as sunspots appearing more often, then fading, then returning, as if the sun has seasons of mood, except the seasons are magnetic and the calendar is solar. Meanwhile, the core keeps doing its quiet work with the patience of someone sleeping through a thunderstorm. Fusion doesn't surge because a sunspot appears. The core's temperature and density are set by gravity and the star's overall equilibrium, and those don't care about day-to-day surface weather. The The core has stability built into its feedback loops and its enormous thermal inertia. It's slow to change, and that slowness is protective. Even when the sun is highly active, the energy in a flare is tiny compared with the sun's total steady output. Flares look intense because they're concentrated, like a camera flash in a dark room. The sun's overall power is a constant flood. The core keeps pouring energy into the interior in an even stream, and the outer layers spend it in different ways. Some becomes the light and heat that reaches you. Some powers motion in the plasma, and some gets temporarily stored in tangled magnetic fields until the field suddenly rearranges and releases it. There's a gentle human lesson hiding here, because the universe loves doing that when you least ask for it. The most dramatic thing is not always the most important thing. The surface fireworks get attention because they're visible. The core gets ignored because it's steady. But the core's steadiness is the foundation under every bright flare you'll ever see. A star can afford to be wild near the surface because the deep interior holds the structure stable. The core is the quiet spine under the noisy atmosphere. If your mind wanders to how surface magnetic moods can touch Earth, auroras, radio hiccups, satellites having a bad day, you let that be a small passing thought and then release it. The deeper comfort is the separation itself. The core doesn't send mood swings. It sends neutrinos, quiet, immediate whispers, and a steady flow of energy on a long delay, like the calmest subscription service in the universe. No cancellations, no surprise price hikes, no crocodile dunks sunscreen upsell at checkout. You rest in that layered sun, a calm heart below, a restless atmosphere above. The same star can be both because physics lets different regions behave differently. And as that contrast settles into your breathing, a new curiosity starts to form. Not about the surface fireworks, but about the deep environment itself, what it would mean in simple physical terms to be near such pressure and density, without turning it into nightmare fuel, just letting the reality be strange, clean, and quietly awe-filled. That contrast, quiet heart, restless outer layers, makes it tempting to imagine yourself dropping straight through the sun like it's a glowing ocean you could somehow dive into, aiming for the deepest point just to see what it feels like. Your brain tries to turn it into a scene. You, drifting deeper, the light thickening, the hum getting louder, the core waiting like a secret room at the center of a palace. A gentle reality check slides in, not to ruin the mood, but to make the awe cleaner. Touching the sun's core isn't really a thing, because there's nothing down there that behaves like a surface. No floor, no wall, no solid object to press your hand against and say, yep, that's the core. The core is a region, an environment, more like a set of conditions than a place with boundaries you can knock on. So when you imagine getting close, it helps to imagine it as awareness rather than a body, because a body brings all the wrong assumptions. Skin, breathing, bones, a sense of me staying intact while the universe does its thing nearby. The sun's core doesn't offer that kind of courtesy. It's not malicious. It's just indifferent, like gravity itself. A physical body in those conditions would stop being a body so quickly that time wouldn't even get the chance to feel dramatic. And the reason isn't one single villain like heat. It's the whole environment piling on at once, calmly, relentlessly, the way the sun does everything. Start with pressure, because pressure is the core's signature. You already felt gravity's hug and the way the core supports the weight of the star above it. If you could translate that into something your Earth brain understands, think of the pressure at the bottom of the ocean, water pressing from all sides, squeezing every empty space, making the deep feel heavier than the surface. Then stretch that feeling beyond anything ocean water can do. The core isn't deep the way the Mariana Trench is deep. It's deep in the way the center of a star is deep, with an overhead weight measured in the mass of the sun itself. At those pressures, matter doesn't get to be fluffy. It doesn't get to keep little gaps. Everything is pushed close together. Even the idea of empty space inside atoms becomes less meaningful because the electrons aren't sitting in polite orbits anyway. The material is already plasma, nuclei, and electrons moving in a dense crowd, and the crowd is held tight. If you try to imagine standing there, it would be like trying to stand inside a pressure wave. There's no stable platform. There's only compression as a fact of existence. Then there's density, the quiet cousin of pressure. In the core, density is high, far denser than anything you deal with in ordinary life, more like a heavy metal than a gas, except it's still a fluid plasma with no solid structure. The core doesn't look like a chunk of lead, but in terms of how much stuff is packed into a given volume, it's in that neighborhood of heavy, and then some. That's why photons have such a miserable time escaping. Not because the core is trying to be secretive, but because there are simply too many charged particles in the way. So touch becomes a weird word. What would you be touching? You'd be immersed in a thick, charged fluid where every point is full of particles moving fast, colliding constantly, sharing energy constantly. It would be less like touching an object and more like being inside a storm that never stops, except the storm is everywhere and perfectly contained. Temperature adds another layer, and it's easy to get distracted by the big number. The core's temperature is around 15 million degrees Celsius, an absurd statistic that your brain tries to turn into a cartoon flame. But you've already softened that idea. Temperature is motion, and motion here is relentless. Particles in the core are moving at huge speeds, colliding, bouncing, exchanging energy in a way that keeps everything in a hot equilibrium. A body survives heat on Earth by having stable structures, molecules, tissues, able to absorb energy without instantly falling apart, and by having a surrounding environment that can carry heat away or allow cooling. In the core, there is no cooling the way you know it. There's only immersion in an environment where everything around you is already energetic beyond your chemistry's ability to remain chemistry. Even if you tried to imagine a supermaterial suit, you'd run into the next truth. The core isn't a place where materials have the chance to behave like materials. At those temperatures, atoms don't hold onto their electrons. Everything becomes ionized. Any object becomes part of the plasma crowd, indistinguishable from the environment because the environment is the dominant state. That's not horror. It's just a clean description. The core doesn't support individuality. It supports equilibrium. Radiation is the next quiet problem. The energy released by fusion begins as high-energy radiation, gamma rays, and energetic photons that immediately get absorbed and re-emitted, scattering endlessly through the dense plasma. You don't get a clear beam of light down here. You get a constant, embedded field of radiation interacting with matter all the time. In normal life, radiation is something you picture as a ray, a line, an invisible beam. In the core, it's more like part of the texture of the environment. Energy constantly being swapped between photons and particle motion. So if you insist on imagining arriving there, the most accurate image is not you walking into a room, but you dissolving into a set of conditions. Pressure closing in from all directions, density filling every space, temperature meaning motion everywhere, radiation meaning energy exchange everywhere. Arrival becomes becoming part of the medium. Even the concept of a boundary gets fuzzy. The core is defined by where most of the fusion happens, not by a wall. Fusion happens because temperature and density are high enough, and those quantities gradually change with radius. So you don't cross a doorway labeled core. You drift deeper, and the probability of fusion rises. Drift outward, and it falls. It's a gradient, not a border. That gradient matters because it keeps the sun calm. There isn't a single thin layer doing all the work like a brittle filament that could snap. The core's energy production is distributed through a volume. If one tiny region gets slightly hotter, the feedback loops you've already felt kick in, expansion, density change, fusion rate adjustment, nudging it back towards steady. The core is stable in part because it's not concentrated into a single point of failure. There's also a subtle point that makes touch even weirder. At the center, directions lose meaning. Gravity pulls inward from all sides, and at the very center, the net pull cancels out. Not because gravity disappears, but because it's perfectly symmetric. So the center is a still point in terms of direction, even though particles are still moving like mad. It's the most intense environment paired with the least directional bias. Your instinct to say down doesn't apply. Everything presses in equally. Everything is held equally. The core feels like a hug with no obvious arms. And if you try to imagine feeling anything, your senses start failing one by one. Touch relies on surfaces. Sound relies on pressure waves in a medium and ears designed to pick them up. Sight relies on photons traveling cleanly to your retina. None of that maps neatly onto a dense plasma where photons don't travel straight and surfaces don't exist. The core is physically real, but it's sensorially alien. You can understand it better with concepts than with imagined sensations. So the gentlest, most honest way to picture being there is to stay as that point of awareness you've been using, a quiet observer that doesn't need oxygen, doesn't need a body, doesn't need eyes. You drift through the crowded plasma and notice the organization. The way charge screening smooths electric forces, the way electrons rearrange quickly to keep neutrality, the way pressure balance prevents collapse, the way fusion occurs not as a detonation, but as a rare success in a sea of near misses. You notice how violent becomes the wrong emotional label. Collisions are constant, yes, but they're constant everywhere. There's no surprise spike, no sudden monster. The core is intense, but the intensity is normalized. It's like living next to a waterfall. At first it seems loud, then your brain stops treating it as an alarm and begins treating it as a steady background. The core is a waterfall of interactions, and the sun has had billions of years to treat that as normal. That normality is part of why the thought can be calming rather than unsettling. The sun's core isn't a chaotic inferno waiting to lash out. It's a stable environment where extreme conditions produce steadiness through feedback. Gravity is firm. Pressure answers. Fusion proceeds slowly. Photons wander. Neutrinos slip away. Waves ripple through as quiet evidence of structure. Everything is held. Everything is paced. Everything is contained. And maybe the sweetest part of this reality check is what it does to your imagination of risk. The core isn't a place you could approach and be harmed by a sudden mood swing. It would simply absorb any physical intruder into its environment, instantly, impersonally, the way the ocean absorbs a drop of dye. Not cruel, just absolute. The sun doesn't have to defend itself. It doesn't have to react. It just exists in conditions where you cannot remain you. And that's enough. That idea can land like a strange kind of relief. The core is not a villain. It's not even a character with intentions. It's a steady engine that runs on the simplest particles and the deepest forces, held in balance, changing only as slowly as its own clock allows. When you let that be true, the core starts to feel less like a threatening furnace and more like the universe's most consistent source of patience, an environment so stable that it can power a world while remaining entirely indifferent to applause. Your awareness drifts there for a moment longer, letting the facts settle without extra decoration. No surface, only conditions. No burning, only motion. No chaos, only a regulated crowd. No touch, only immersion. And from that calm clarity, the next thought begins to glow at the edge of your mind. Not about what it would do to you, but about what it quietly does for everything you've ever known. That quiet doing for everything starts to feel almost unfair, because you've spent all this time near the sun's core learning how little it cares about spectacle, and yet the entire surface of your life is built on its steady output. The core doesn't make speeches. It doesn't brag. It doesn't even send you a courtesy email saying, "Hey, still shining today." It simply keeps converting tiny bits of mass into energy, and the rest of the universe keeps cashing the check. You can think of the core as a cosmic battery, but not the kind that drains because you forgot to close one app. More like a battery the size of a star that releases a smooth, dependable current for billions of years because it's built out of patience and physics. The current starts as fusion energy in the core, gets tangled up in plasma, diffuses outward through that long, wandering photon commute, and finally escapes the surface as light that spills across space like a slow wave that never stops arriving. The funniest part is how normal it feels on Earth. A sunrise is treated like background, like wallpaper you don't notice until it's unusually pretty. The core has been working the whole time, and your planet just keeps catching the spillover. No effort required on your end. You don't have to earn daylight. You don't have to deserve warmth. You just rotate into it. Even tonight, while the sun is off for you, it isn't off. It's shining for the other side of Earth, pouring energy onto oceans and deserts and rooftops, fueling the day for people who are currently complaining about heat while you're trying to fall asleep. The core keeps sending power outward regardless of who is awake, because it doesn't do schedules. It doesn't care about time zones. It doesn't know what a calendar is. It just knows balance. That balance becomes the first connection to your body. Your circadian rhythm, your internal sense of day and night, is a biological habit shaped by sunlight. The core's steady output creates reliable daylight, and reliable daylight trains life to expect patterns. Your brain learned, over countless mornings, that light means activity and darkness means rest, and your hormones adjust accordingly. You're lying here trying to wind down, and part of what makes that possible is the predictability of the cycle. The core's consistency becomes your body's permission to relax. This is the deep, sleepy irony. The sun's core is absurdly intense, but its effect on your life is gentle and rhythmic. It doesn't shout at your biology. It sets the tempo. It gives you morning brightness, afternoon warmth, evening softness, nighttime absence. Your body responds with its own slow chemistry, shifting between alertness and sleepiness, like an echo of the star's steady heartbeat. That same steady output powers the world's largest, laziest engine, weather. Earth's weather isn't mainly driven by Earth's interior heat. It's driven by sunlight, by uneven heating across a rotating sphere with oceans, land, ice, and an atmosphere that moves because it must. The core's energy arrives as light, gets absorbed by the ground and the sea, warms air, evaporates water, builds pressure differences, drives winds, and stirs the planet into constant motion. If you want an image that feels calm rather than chaotic, picture Earth as a slow-turning marble under a warm lamp. The lamp is the sun, and the lamp's power source is the core. One side of the marble warms and brightens, the other cools and darkens. Warm air rises, cool air sinks. Water vapor lifts, condenses, falls as rain. The movement is complicated up close, but the cause is beautifully simple. The core keeps the lamp on. The oceans are especially good at making this feel real. Sunlight warms the top layers of seawater, and the heat doesn't vanish. Water holds it, spreads it, stores it, releases it slowly. That stored heat shapes currents, feeds storms, softens winters, and keeps coastal places more moderate than inland places. Even if you never think about it, you live inside an ocean-shaped battery charged by sunlight, charged by the core. And there's a pleasing continuity here. The core's energy doesn't only exist as light. It gets turned into other forms and held in them. Heat in the ocean, motion in the wind, potential energy in water vapor that rose and condensed into clouds, chemical energy inside plants. The core sends energy outward, and Earth becomes a messy, creative accountant, converting it into all the currencies life knows how to spend. Plants are the most elegant conversion. A leaf doesn't see the sun's core, but it relies on it anyway. Photons arrive, are absorbed by pigments, and their energy is used to build chemical bonds. Light becomes sugar. The core's steady output becomes stored energy in a form that can be eaten, burned, fermented, and argued over in comment sections. You can trace your own ability to think back to that chain, sunlight into plants, plants into food, food into your cells into your brain's electrical chatter. The core isn't in your body, but its energy is everywhere in your body's history. And if you want a quietly mind-bending detail, remember the time delay you followed earlier. The sunlight that hits a leaf today began deep in the sun long ago, then spent ages bouncing through the sun's interior before it ever escaped the surface, then crossed space in minutes to reach Earth. So a leaf is catching an ancient story that only recently arrived. Life is powered by delayed messages. That should be unsettling, but it isn't, because the delays are consistent. The core is steady enough that ancient still means reliable. The same goes for the warmth stored in fossil fuels, which is basically sunlight that got saved for later by accident. Old plants captured sunlight, got buried, got transformed, and millions of years later humans learned to set it on fire and call it progress. You could say the core's energy has been sitting underground on Earth like a savings account, waiting for a species with questionable stress management skills to discover it. Even your modern world, cities lit at night, machines humming, screens glowing, still runs partly on the sun's past generosity filtered through geology, which is a slow, dramatic way of saying the core has been paying bills for longer than anyone asked it to. Even the shape of your day is built around this. The difference between a morning that feels crisp and a midday that feels heavy comes down to how sunlight warms surfaces, how air moves, how humidity rises and falls. That change in feeling on your skin, warm, cool, dry, sticky, starts as fusion deep in the core. It travels outward, becomes light, crosses space, lands on your world, and then gets rewritten into weather. And because the core is so steady, weather becomes patterns rather than pure randomness. You get seasons because your planet is tilted. You get day-night cycles because Earth rotates. You get climate zones because the sun's angle changes with latitude. All of that depends on the fact that the sun is not flickering. The core's balance creates a stable, predictable energy source. If the sun were erratic, life would have a much harder time building routines. Plants timing growth, animals timing migration, you timing sleep. That doesn't mean Earth is always calm. Weather could be dramatic, and people love drama. But the drama rides on a stable input, like improvisation on a steady beat. The core keeps the beat. Earth improvises. You can feel the comfort in that even while you're lying still. Your room is quiet. Maybe there's a fan humming. Somewhere outside, air is moving, clouds are shifting, water is evaporating and condensing. All because the core's steady output warmed one region slightly more than another. You're resting inside a planet-wide circulation system powered by a star's calm heart. The core also shapes something more subtle, the way your mind associates light with safety. Humans are visual animals. Brightness tends to feel safer than darkness, even when that's not logically true. The sun trained that instinct. Daylight means easier navigation, easier gathering, easier noticing. Night means uncertainty. You're here on purpose, letting night mean rest instead of threat, and that choice is easier when the days are predictable. The core's reliability gives night its boundary. You can relax into darkness because you trust that morning exists. That trust is one of the biggest gifts the core gives you, and it's easy to miss because it arrives as normal life. The core keeps the sun shining steadily enough that you can build a world around predictable cycles. Crops, clocks, sleep, holidays. Even the way you measure time, days, years, depends on a star that doesn't change its mind. You can't make a calendar around a candle. You can make one around the sun. And somewhere under the sarcasm about productivity apps and ancient sunscreen, there's a soft, simple awe. The core doesn't know you, but it supports you anyway. It powers the winds that cooled you on a hot day. It powers the plants that fed you. It powers the light that trained your body when to wake and when to rest. It powers the gentle warmth that made your species believe the world could be understood and predicted, at least enough to try. You sit in that grandeur without forcing it. A dense, hidden region inside a star keeps turning the universe's simplest element into a slightly heavier one, and the released energy becomes the stage lighting for an entire planet's story. Not because anyone planned it, because physics stayed consistent long enough for life to take advantage of it. And that makes the core's calm feel even more profound. It isn't just a calm place. It's a calm source. A slow, steady battery that has been feeding Earth's air, oceans, and biology with quiet generosity so long that your nervous system learned to expect dawn the way it expects breath. The core keeps humming, and your world keeps moving, and your body keeps easing closer to sleep, carried by a rhythm older than language. That trust in dawn sits in you like a warm weight, and it brings the next thought in softly. Even the sun has a future, and its future is shaped by the same calm rules you've been floating through. Nothing abrupt, nothing theatrical, just the slow consequence of a core that keeps turning hydrogen into helium, one rare success at a time, for so long that change looks like a gentle shift in color rather than a sudden break. The core's clock keeps ticking in helium. The very center grows more helium-rich, not because the sun is failing, but because it is working. Hydrogen in the middle becomes less common, helium becomes more common, and the core adjusts in tiny ways to keep supporting the star above it. The adjustments are so smooth that the sun stays familiar from the outside, like a friend who's quietly growing older while keeping the same voice. Far ahead, so far that numbers stop being helpful, the center reaches a turning point. The hydrogen there is no longer plentiful enough to keep fusion going in the exact same place and in the exact same steady pattern. The center does not switch off. It simply changes role. Gravity, faithful as ever, tightens its hug. The helium-rich core begins to contract, growing hotter and denser as it compresses, while the surrounding region still contains plenty of hydrogen. Fusion doesn't end. It migrates. Hydrogen fusion settles into a shell that wraps around the contracting helium core, like a glowing ring of activity surrounding a quieter center. That shell produces a strong flow of energy, and the star responds the only way it knows how, by reshaping itself until inward gravity and outward pressure agree again. The outer layers expand. They swell outward over time, and as they spread, the surface cools. A larger star with a cooler surface drifts toward redder light, softening in color even as it brightens in total output. This is the sun's red giant era, and it sounds like a villain transformation only because humans like dramatic names. In reality, it's the star aging with a slow dignity. The core becomes compact and dense. The energy production shifts to a shell. The outer atmosphere grows vast, diffuse, glowing. The sun becomes, in a way, more gentle to look at, warmer in color, broader in the sky, while remaining powerful simply by being larger. Deep inside, the contracted core keeps heating, and helium starts to matter in a new way. Helium nuclei repel each other more strongly than protons do, so the threshold for helium fusion is higher. The core climbs toward that threshold slowly, under gravity's persistent squeeze, and when it finally reaches it, helium can begin to fuse into carbon, and then sometimes oxygen. The sun becomes a quiet factory for elements that feel more like stuff to you, materials that can become rocks and worlds in other places, in other times. There's a detail that sounds sharp in textbooks, but can be held gently here. In a star like the sun, the contracting helium core becomes so dense that it doesn't expand and cool in the usual smooth way as it heats. So when helium fusion starts, it can start quickly. Quickly, in this context, still isn't a Hollywood explosion. It's the star rearranging its internal balance in a short burst of adjustment, releasing energy that mostly goes into loosening the core's tightest squeeze. The core expands into a new comfort zone, and the system settles, as if the sun had been holding tension for a long time and finally released it. After that, the sun spends time with helium fusion in the core and hydrogen fusion in a shell outside it. The star remains large and luminous compared to its earlier life, glowing with a different internal structure, but still governed by the same quiet principle. Gravity presses, pressure answers, balance holds. In the center, carbon and oxygen slowly accumulate as helium is used up. Eventually, helium in the core becomes scarce too. Here the sun meets its gentle limit. A star of this mass cannot keep climbing the fusion ladder forever. The conditions needed to fuse carbon steadily in the core belong to heavier stars with heavier gravitational hugs. The sun, instead, reaches a point where core fusion fades, and the star begins to shed what it can no longer comfortably hold. The outer layers, already expanded and loosely bound, start to drift away. They peel off over time in great, slow breaths, winds and pulses carrying gas outward into space. The star releases an envelope of glowing material that expands away like a soft lantern being opened, bright for a while, and then thinning into the dark. People call that a planetary nebula, which is one of those names that survived purely because it sounded pretty and nobody wanted to admit it was inaccurate. What remains is the core itself, a white dwarf, small compared to the sun's swollen size, but incredibly dense, about Earth-sized, held up by quantum rules that act like a final internal skeleton. It no longer shines by making new energy through fusion. It shines by leftover heat, radiating what it has stored, slowly cooling over immense spans, a quiet ember in space that takes its time even in fading. That's the sun's ending. Not a crash, not a violent tearing apart, not a final scream. A long expansion, a long rearrangement, a gentle shedding, a compact remnant that cools. It's almost comforting how consistent it is with everything you've learned about the core tonight. The sun spends its whole life turning intensity into steadiness. Even its finale is mostly a change in structure rather than a sudden loss. And the story doesn't stop at what remains. The gas the sun releases doesn't vanish. It drifts into the galaxy's shared air, mixing with other material, carrying along helium, carbon, oxygen, and trace elements. That material becomes part of future clouds. Somewhere, long after the sun has become a quiet white dwarf, those clouds can gather again, and gravity can begin another slow hug, and new stars can light up with their own calm cores. The sun's deep work, simple particles, long patience, feeds a cycle that keeps going without needing applause. So the core you've been visiting isn't only the source of your daylight. It's part of the galaxy's ability to keep making new stories out of the same ingredients. Hydrogen becomes helium. Helium becomes carbon. Carbon and oxygen wait. Gas drifts. New clouds form. The universe keeps recycling, not out of sentiment, but because the rules make recycling the natural default. All of that grandeur can rest lightly in your mind, because none of it demands action. The sun has its timeline. Your body has its timeline. Tonight only needs softness. The image of the sun in the far future can be held without fear. A huge, warm, red glow filling a sky that no human will see. A star expanded into a calm, luminous envelope, breathing its outer layers away over time. Then a small, dense core remaining, still warm, still shining quietly, cooling so slowly that ending feels like a word that doesn't fit. The room around you stays simple. The night stays quiet. The fan keeps its steady hush, if it's there, and that hum feels a little like the sun's own steady commitment translated into something your body understands. Your breath moves the way the sun's balance moves. No rush, no sharp edges, just a gentle exchange. Thoughts can thin out the way the sun's outer gas thins as it drifts away, spreading, fading, becoming background. The mind doesn't need to grip every idea. The mind can release. The core remains where it has always been, deep in the sun, doing its slow work on the other side of Earth, unchanged by your attention. That indifference is kind. It means you're allowed to rest. And as the last image softens, the crowded plasma, the rare fusion successes, The neutrino whispers the long photon commute. Language starts to feel unnecessary. The story becomes a warm atmosphere rather than a sequence of facts, and your body takes over, turning listening into resting. Breathing in feels like warmth gathering. Breathing out feels like weight leaving. The sun continues its quiet work without asking you to watch it, and the quiet is enough. Your eyelids grow heavier, and the vast timeline of the star becomes a comforting blur, like distant light through a curtain. Everything important can keep going, held by rules older than language, while you do the simplest, most human thing. Sleep arrives in its own time, soft and unforced, and the last sensation is a calm warmth with no need for a source, fading gently into dark. The thoughts that remain are slow, rounded at the edges, like stones warmed all day and still holding a little heat in the evening. The sun is far away, and also, in a quiet way, always present, because the light it sends has shaped your world so completely that your body learned to trust the rhythm without ever seeing the machinery behind it. Outside, the planet keeps turning. On the other side of the world, morning light is spilling across rooftops and water and trees, and somewhere a person is blinking awake, completely unaware that the warmth on their face began as a rare, tiny event deep in a crowded core. That ignorance isn't a failure. It's a gift. The universe can be magnificent without needing your constant attention. In here, in your room, everything is smaller and safer. The air touches your skin. The bed holds you. The sounds are simple. Maybe a fan, maybe distant traffic, maybe nothing at all. And each sound is just another proof that you're already in a place where nothing is required. The sun's core stays steady in your imagination, not as a furnace, but as a quiet heart of motion and balance. Gravity holds. Pressure answers. Energy flows outward with patient certainty. Even the far future feels gentle when it's seen as a slow change rather than a sudden loss. Your breathing becomes the only timeline that matters for a while. In and out with space between. The mind can loosen its grip and settle into that space, the way dust settles when the air finally goes still. If a thought tries to rise, it can pass through like a neutrino, leaving no mark. If an image lingers, it can fade like an old photon, finally finding open space. Nothing needs to be solved. Nothing needs to be finished tonight. Only rest. The room around you stays simple. Air moves gently, and every small sound becomes softer, like it's being padded with cotton. Somewhere beyond the walls, the world keeps turning, but you don't have to turn with it. Your job is only to be here, heavy and safe, letting the day slide off you the way warmth slides off sunlit stone after dusk. Picture the sun far away, still working, not for you in particular, but for everything. Deep inside it, the core keeps its quiet agreement, gravity pressing in, pressure answering out, an endless, patient handshake. That steadiness can be yours for a while. You don't need to rush. You don't need to fix anything. You can let thoughts pass through like neutrinos, clean, quick, leaving no trace. If a thought lingers, let it drift and thin, like a photon softened by countless gentle collisions. Let your shoulders drop. Let your tongue rest. Let your forehead smooth. Each breath can be slow and unforced, arriving when it arrives, leaving when it leaves. Nothing is chasing you. Nothing is waiting at the end of the next minute. The night is allowed to be quiet, and you're allowed to match it. The images fade to simpler shapes, a red glow in a future sky, a small white ember cooling over ages, a calm darkness that asks nothing from you. Even that far future feels kind, because it changes slowly, the way evening deepens without needing permission. And in this moment, the only light that matters is the quiet one behind your eyelids. The fan hum, the dark, the weight of the blanket, all of it is enough. You can rest. You can let your body sink. You can let sleep take over gently and naturally, as if you were always meant to, right here tonight.